And I'll just start recording. If there's anybody else that wants to record, you'll have to, I think you have recording capability. So go ahead if you'd like to record. It'd be good if someone else records.
I'm going to record, Rick, if that's all right, just
Great.
so that I can get the experience of doing it.
Yeah, go ahead. I have to allow it, I guess. So I'll allow record there. Anybody else? John, perhaps? I'll give you record. Anybody else? Sorry. Sandy sometimes does. I'll allow record there. Okay. Looks like we're ready to go. Welcome everybody to Tuesday night. Therefore, it's the Keshe Plasma Reactor group. Let me just, I was going to show my face briefly here and to pin that on the second screen. There I am. And just a bit. All right, now I'm set up. Welcome everybody to the Keshe Plasma Reactor group for Tuesday, January 5th, 2016. Now we're pretty much ready to go, I think, so we'll just get into it here. I've got a picture by Selma. Let's get that up on here. And stop this spotlight video and share the other. Okay, there we go. Now, Selma, are you able to speak on your microphone? Can we hear you?
Yeah, Rick, I'm here.
Okay, I got you, right. Do you want to
start off, can you start off with the question, 2 questions?
hang on just a second here. I have to make an alteration in my setup. There we go. Okay. Sorry, go ahead again.
The question below right hand side.
Okay, yeah. We can see most of it or part of it. Something about if a spot of GANs can make something dynamic. Can you read the question? It doesn't come through on the picture. That's all I have of it is what we see there.
So you cannot make it large?
No, the whole thing is one picture. It's not 4 separate pictures. That's why I emailed you about this, that I need to have it in a different
I'll read it too, no problem. If a spot of GANs can make a coil dynamic, can a coil very small make the GANs dynamic? You understand?
Well, that's a great question. I love it. Yes, and this is actually something I've been pondering myself. Yes.
Yeah.
So the GANs already is dynamic. If you use a coil on it, you'll probably add some energy to it, but the GANs is not a static thing. It's constantly in motion.
So rather the GANs make the coil rather than the coil make the GANs?
Yes.
So he has that. He says the spot of GANs can make a coil dynamic. Or can you read the question again, please?
If a spot of GANs can make a coil dynamic, that is from Keshe workshop. So I'm asking, can a coil very small make the GANs dynamic?
Right. Okay. So
yeah,
the idea is that coating the coils will make them more dynamic, more able to interface with the environment and whatnot. It's a transition material.
Like as in strength of the coil?
Well, I don't know if it would be strength or whether it would be just enabling certain things to happen that may not happen with just a straight nano-coated coil.
Yeah. So rather it
What
goes both ways.
what was your opinion on that, John? You were going to say something
Well,
there.
the way I see GANs is, well, as Kesh described, there's now 6 states of matter. We got solid, liquid, gas, nano GANs, and plasma. Um, the GANs is one step closer to plasma than the nanomaterials are. So it's in its very nature is going to be more dynamic than the nanomaterials to begin with. We put the GANs on the nano coils to act as an energy source to infuse the coils with the plasma energy that the GANs contains.
Right, so that would go along with the first part of his question. If a spot of GANs can make a coil dynamic, right? That makes sense there.
Yep.
So, okay, go ahead.
So when you put, if you were to take a nano coil and put it in GANs, that coil is going to be a conduit for the plasma that the GANs is releasing.
But
Not the other way around.
what if the coil is say activated in a certain way? Like what if it was a plasma based coil, or what if it had certain kind of fields that may come out that could perhaps stimulate the GANs or make it rotate faster?
Well, I've tried using magnets and electromagnets, coils, fields on the GANs itself, and it doesn't seem to do anything to it.
Right,
There's
I
nothing.
that's
It's
about
nothing visible. It may be
my
something in the
experience
or the
too.
micro, but
And it might be
um,
possible with the copper GANs to get certain kinds of effects, like a certain kinds of what do you call it? Not magnetic, but not paramagnetic, but diamagnetic effects might be possible with. I could possibly see that with the copper GANs, but yeah, all generally it doesn't respond that much to these kinds of fields. But on the other hand, maybe that's not the kinds of fields that it would tend to work in. For example, it could be that under certain fields, the GANs could speed up internally inside of each of the GANs, what do you call it, monomolecules. The molecule actually speeds up, but to us, to the visible eye, we don't see any difference until it speeds up to a certain point where it might give off light or give off heat or some other indication that there's a release going on. But it might be essentially storing energy. There was a scientific paper I read recently that talked about having a magnetic field um, going through these some particular nanomaterials. It was a molecule, I forget exactly which one it was, but they were able to speed up the molecule from its usual billions of spins per second up to a terahertz range, into the tens or hundreds of terahertz, virtually immediately with just the application of a magnetic field. And I was thinking of that applied to a GANs, and if it was true there, then just the application of certain fields, making a certain environment, in other words, and then having the stimulation of the coils or stimulating the coils, one way or the other, that these ambient fields seem to make a huge difference in the dynamism, the dynamic rotation of these particles. So I'm wondering if that applies, and that if so, that would be an important factor to enter into all this. Like, for example, in the original rotating spherical reactors, Mr. Keshe has talked about having what was it called? Not light, but a weak magnetic field was advantageous, like a consistent magnetic field through the unit, other than just the Earth's magnetic field. more strong than that, let's say. And that helps to polarize the ions and so on. That's my interpretation, but it works more in a plasmatic way, of course.
Or
If
is it rather, is it rather the GANs have the strength, but the coil assists with the flow of the field?
well, the
Yeah.
nanomaterials, the nano-coated copper or plastic or whatever you're going to use, the nanomaterials only act as a conduit for the plasma. They're
Yeah.
they're they're not emitting plasma themselves. They're allowing it to flow through it. That's the way I understand it. And if what Nassim Harriman has come up with over the last 6 months or a year or so, it appears that if you look at the different states of matter, if we go from, say, a solid to a GANS, the solid is a very stable, very compact atom. It's a billiard ball. It's a very, very hard, very, very stable Coulomb barrier that we're seeing. With the GANs, it's a very big, fluffy, loose atom. It takes up considerably more volume. Like if you do it with the Planck length as Nassim Harriman does, um, the, uh, the GANs atom would be releasing a tremendous amount more information, which in this case would be what we are calling the plasma, because the ratio between the surface area and the volume is significantly higher than if it was in a nice compact solid state. Um, so also with
Yeah.
his information, as you loosen these atoms up and they release more and more energy, you're dealing with a near infinite amount of energy within each atomic. I don't want to use the word particle because it's not within each atomic vortex. So by adding a nanocoil to that, unless that nanocoil was absolutely and utterly pulsing with plasma to a degree larger than the available information coming out of the GANs atom, the flow would be from the stronger to the weaker, which would be from the GANs atom to the nanomaterials. Does that make sense to you?
Yeah, yeah, it makes sense. No worries. Uh, the GANs itself have the strength like a plasma, but the
Yeah.
coil,
It's
maybe,
once
maybe
the
the
GAN.
coil, because of the copper, it helps like when it goes through the wiring.
Oh, no. The copper does nothing. Once it's nano coated, the copper is structure. It could be plastic, it could be hair, it could be anything. It doesn't matter at that point. It's just the framework that holds the nanomaterials.
Okay, okay. You know, I was thinking maybe it helps in that little bit. You know.
Well, the structure would
Um,
definitely make a difference. Like if you have,
in the geometry of the field, certainly.
well, in terms of the actual surface, some surfaces will support certain kinds of plasma, and others might not. Let's say just because it's nano coated doesn't mean it's the right nano coating for supporting the plasma. Um, Unless we mean by nano coating, by definition, it supports a plasma. If you have the right nano coating on any material, maybe
Well,
that's
that's what
a
was
better way
included
to
in the
define it.
workshop.
Okay, okay. Just my thinking. You know. Okay.
Yep.
Like what you're talking is what we'll be using more than coil, but now we're using coil, right? Copper. So that's where we get the hexagonal field and all that because of the coil. Yes or no?
Well, the geometry, I don't think it's necessarily the coil that's doing that, but the geometry would definitely have something to do with it, I'm sure.
Yeah, correct.
Geometry is just a it's a flow of plasma. That's where you're directing your plasma.
It sounds like
You-
Armin. He's bringing us back to plasma. Thank you, Armin.
Mhm.
Okay,
Thank you, Armin.
say that again, just to reinforce it there, Armin.
I said, you know, just imagine as a coil, it's a directional field that you just coiling it. It's a right way or left way. It's just a direction.
The hexagonal shape comes from the fields from the coils, the interaction from the fields of the coils. Each coil interacting with the other creates the hexagonal field. And in the nano material, copper and different metals have different energy levels and different plasma flows through them. They're not the same at all. The structures are not
Well,
the same.
according to Nassim and his work for the last little while, the hexagonal, the tetrahedron or the star tetrahedron is the actual geometry of the fundamental field. So when you start increasing that in orders of magnitude in would it be volume, going from atomic to molecular to matter to regular what we live in to the cosmic state, it's simply a fractal. So the if you take it to the simplest form, the vortex itself is going to inherently generate that
Yeah. If you have a perfect system, we have imperfect materials. We have imperfect materials, so that's why you have to play with them.
That's right. So, but I think the hexagonal structure is more from the fundamental field, because we see the hexagonal structure in a sphere of plasma. We still get the hexagonal structure and not necessarily coil. Like there's no coils on Saturn.
It's not a coil. It's the way you position your coils.
Exactly. The positioning creates the hexagonal field.
Position in relation to what are you talking about? Are you talking about the rotation?
The positioning between each coils, the interaction between those coils, the way you set them up, creates the hexagonal field.
Well, what kind of setup are you talking about? What difference would it make with their, like most people have
90 degrees difference. When you put a 90-degree difference,
right,
and you collected actually 90-degree difference.
So the 90 degrees creates the hexagonal pattern. Is that what you're saying?
I think so.
Is that what you mean too, Brett?
Create that.
Yeah, it just appears that the hexagonal tendency is inherent in the fundamental core of the plasma we're working with. And if we wind up with a balanced system, it's going to inherently make the hexagonal shapes. But they'll actually be a three-dimensional. It'll be more of a double tetrahedron, one on top of the other, but one upside down.
It's a honeycomb.
Well, I'm basing this on Nassim's work, which makes total sense to me, and he's doing it mathematically, and he's showing that if you go right down to the smallest core field that you can have, it is inherently going to make a hexagonal field. So I'm thinking that since we live in a fractal anyway, that field is going to try to reproduce itself as many times as it possibly can, depending upon what level of fractal you're looking at.
And that's, I think, why they have so much trouble with some of the tokamak type reactors and so on. They have one now that they're working on, and they've had to twist all the magnets all around the circle of the cyclotron type system they're working on. And it's come out to this totally convoluted looking twisted structure. And basically they have a hexagonal shape that they're coming up with by the plasma wants to twist, and they try to make it go straight and flat and round in a regular circle, but it doesn't want to go that way. It wants to twist, and where those twists and bends are must be the natural bends of the hexagonal shape.
That's what it appears, looking at the way it's described in the math anyway. That's what it appears to be. Now, if we wind up with a balanced system, is any balanced system going to inherently create the hexagonal field, or is it only certain types of balance systems? I don't know yet.
Do you try to start with a hexagonal coil shape, or is that trying to force the plasma into something that it may not want to be that particular? Maybe it wants to be, 20 degrees off from that, or it wants to twist in a certain way that's not the way that the hexagonal shape that we think it's going to be. So how do we know exactly how to conform as closely as possible to that principal, core, what would you call it, fractal shape, I guess.
Well, if we're working with free plasma, ones that we're not trying to stuff into a box, it's just going to inherently take whatever shape it wants to take.
That's a good point.
And if we look at systems like Saturn, Mars, all of the ones that we can see fairly clearly, as if the system is just allowed to do what it wants to do, then that hexagonal just goes up somewhere. When you look at a snowflake, right? That's about as it's a matter state, agreed, but it's still as the water falls and it slowly freezes, the everything inside of the fields inside of it organize into however they want to be, and it pretty much always comes out as a holy cow.
Affected by Met.
Yeah, big time bandwidth issues over there.
Hello, Rick. Hello, Rick. This is Sylvester from South Korea right now. How are you? I'm good. I'm just listening. Sorry. So I'm just listening, John, explanation about hexagonal shapes, and I just have a short comment. I work together with the Japanese scientist called Masaru Emoto with water molecules. The frozen shapes of the water drops, and you probably all familiar with the research with Masaru Emoto did. Mm-hmm, our company worked together with the Hado Institute on certain developments regarding water and liquid. And the human body also absorbed the water in hexagonal, shape and molecular structure. So it is really interesting.
Could you say a little more?
Crystalline structures, we see it in metallic structures. It's all over the place. I mean, that's got to be something important about it, certainly.
Yes, this is the only shape the human body, the cellular surface can absorb the water. So when you drink water, your body basically uses inner energy, the chi, to transfer the water into these perfect combinations of molecular structure. Then this is the only way your body can absorb the water. So once you create the water with the perfect molecular structure of hexagonal, that's the time when you basically can save energy. So one of our developments was in a previous research which we did is once we created the technology to create the water perfect, not just in one particular way of creating this hexagonal molecular structure, but in other levels as well. So then once you drink that water, at least you don't use your own inner energy to transfer the water into a way your body needs.
Yeah, another thing to keep in mind when you're thinking about this as well, it came up when I was listening to Nassim this afternoon. Nature doesn't create two-dimensional things. You can't have an infinitely thin plane with only two dimensions. It's always going to be three dimensions.
It's true.
There's always going to be some depth to it. So when you're looking at your hexagonal structure, expand it out towards you and away from you, as well as left and right and up and down, to get a better picture of what that is actually, what that's turning out to be.
Exactly.
That didn't come out very well. I'm tired. Beeping from me. Yeah, I gotta put my Skype on Do Not Disturb. There we go.
Yeah, I just had this picture come up recently. I wanted to show this. It's a sort of a cyclotron. They call it a cyclotron motion. And basically, it's an electron beam inside of an evacuated bulb. The difference here is that they have these large coils. I don't know if you can see, but on the outside part of the picture there's these red layered sort of coils. They're actually copper coils. There's one on each side of the bulb. They're called Helmholtz coils, and they provide a constant magnetic field through the bulb. And because this electron beam gets shot out, and when it hits this constant magnetic field, it goes in a circle. And I thought, well, that's interesting. So normally that beam would just shoot out straight, but because it's in this magnetic field, it's an electric, no, it's actually a magnetic field. There's an electric field that can be used as well. It's a little different. But this provides a circular path for the electron flow there. And you see, it's not a perfect circle. It's twisted, and it's could even be said to have high points on it in several places. And I wonder if it wouldn't be six-sided if it had an opportunity to, let's say.
I don't
Well,
know. That
Rick,
is, it would be flaws in the coil that might cause that more than anything.
Hey Rick, this is Robert.
Hi, Robert.
Can I share something on
Sure.
these hexagonal things? Let me share my screen.
Yep.
Can you see my screen?
Yes, we see it well.
Okay. Based on Buckminster Fuller's work, the vector equilibrium, which you see here.
That's not a vector equilibrium.
This is the vector equilibrium as Buckminster Fuller describes it. It's made out of tetrahedra pointing inwards and octahedra pyramids, basically. These bases that you see are the bases of the pyramid going inwards, so the apex would all meet at the center. Then maybe I can do a cut here. Not on this plane. Maybe this plane. Okay, you see all the tetrahedra and pyramids meet at with their apexes at the center of this vector equilibrium. And the reason it's called vector equilibrium because all the edges are equal length. And according to his explanation, as the energy travels from around it and through it, the energy does not kind of stop in this entity. It just comes in and flows out without any resistance. So that's why it's in equilibrium. But the icosahedral shape, where all the faces are triangular, the energy gets trapped, sort of. because it's not an equilibrium state anymore. So the hexagonal shape that you see is basically the vector equilibrium looking at it at a certain sort of angle position. Like in this position, you see the hexagonal edges.
Mm-hmm.
So this is where your hexagonal shape comes. And in vector equilibrium, you have if you look at it from here, you have 1, 2, 3, and 1 at the equator, 4 hexagonal sort of paths for energy.
Yeah,
So
the scene goes over this at great detail and explains it very, very clearly. And you need to look at both sides of the equation. This is a partial representation of the contracting side of the equation. And it's that drawing right there isn't complete because it's not a balanced system when you compare it to the expanding side of the equation. And the points on the periphery of that are not equidistant around the sphere that's going to contain it. It's a portion of the vector equilibrium, yes, but it's not complete.
you mean these points?
The mathematically complete model is actually a 64 tetrahedron grid, and it is a absolutely perfect balanced vector equilibrium system. And Nassim goes over it. I think it's his what's it called? Something Valley talk. It's like 6 or 7 hours long, but he goes through it in great detail and explains exactly how he derived at the perfect vector equilibrium. But it is based on hexagonal shapes in the macro. In the micro, it's based entirely on tetrahedrons.
Well, you cannot create what Buckminster Fuller calls all space filling with just tetrahedra. You need both octahedral and tetrahedrons to fill all space.
We're not talking about filling all space. We're talking about a vector equilibrium. And when you look at both sides of the equation, like I mentioned, when you look at the expanding side, which is a sphere, and the contracting side must also balance the sphere. So every point that on the contracting side that intersects that sphere.
Well, spheres are only high frequency.
No. You misunderstand what I'm talking about. The expansive side, which is the magnetical, and the contractive side, which is the gravitational. Where they intersect, it must balance as well. And if you were to put a sphere around this with the sphere intersecting at every point, it wouldn't be a balanced system because the points of the sphere wouldn't be equidistant throughout, or the points of the platonic solid wouldn't be equidistant throughout that sphere.
Well, right, the diagonal of this square would be longer than the edge.
That's why, exactly. That's why I'm saying that's close, but it's not a complete system. Look at Nassim's work. You'll understand what I'm talking about.
Well, I've looked at his work, and I've looked at Buckminster's Fuller work. Nassim just takes Buckminster's work and just tries to do something that makes it his. But it's very simple. If you want a completely balanced system on the spherically, you end up with the icosahedron, where all the faces are triangles, and then every point is equidistant from every other point on the surface.
And this is the shape of the water, if you go with the platonic solids.
The icosahedral or the vector equilibrium?
The icosahedron.
Okay, but so what my understanding is from Buckminster Fuller is the vector equilibrium is the model of the sort of zero point energy, like before it becomes matter, because the energy can flow through it without being trapped into it. But as soon as, well, if you twist the vector equilibrium, it will become a icosahedron. And an icosahedron, you don't have these hexagonal paths anymore, the lowest sort of no resistance path. So the energy becomes trapped in that form, and then it becomes tangible. Because for something to be tangible, it has to contain energy, sort of have trapped energy, with be an entity, energetic entity of itself. So this shape, this model is the point where matter crosses from being tangible into non-tangible, physical to metaphysical. So the icosahedra, where all the faces are triangular, is the matter shape, sort of the material shape of the energy. And it becomes, so with icosahedron shape, you cannot feel all space. It sort of, you trap some of the energy within the shape, and it cannot be continuous anymore. It becomes dissociated from the vacuum in a way. But with vector equilibria, you can feel all space because it contains both the octahedral and tetrahedral forms.
Hexahedron and icosahedron forms, you mean?
I think this form is also called hexahedron. I'm not sure.
Yes.
But
Yes, if it's hexahedron, that's represent Earth in platonic solids.
Yeah, Buckminster calls it vector equilibrium.
Yes, but the person who invented these shapes is Platon itself. This is why it's called platonic solids. So if someone already invented something, we should call it as it is.
Okay, that's fine, but Buckminster Fuller sort of gives it the energetic component to it, why it does what it does through its shape.
And when Platon worked with these shapes of tetrahedron and octahedron and hexahedron and icosahedron, and it was only 4 shapes. It was openly communicated, and it was a 5th shape, which basically represent the universe. And that shape was for long, it was a secret shape. They was not allowed to show, not allowed to communicate. And that is basically represent the space, the universe. And dodecahedron is the shape, which is basically the 6,480 degree and 540 degree times 12. This is how it's look like, and that's represent the universe.
Yeah, there's a lot of different explanations, opinions on the structure of space-time. And I haven't studied all of them, but I'm very familiar with Buckminster Fuller's way of, viewpoint on it, which makes sense to me. So
John, what do you think about all this? I would like to hear, or Rick, what is your opinion about this discussion? Because it's going very long with Robert and me. So I really would like to listen, Rick or John or anyone else.
Well, the way I understand that structure, the geometric structure of it, in an expanding system, you're going to have the smallest, the largest volume within the smallest structure, which is going to be a sphere. In a collapsing system, you're going to have the smallest volume in the largest structure.
Well, the smallest volume, the ratio volume to surface area ratio is the highest at the tetrahedron level. The tetrahedron surface to volume ratio is the highest, whereas at the sphere, it's the lowest.
That's right, and that's where the basis of this comes in. But if you look at the equation of between an expanding and a collapsing system, then as the energy is coming back to the 0 point of that system, it's going to be traveling through that expanding sphere at equidistant points, at every point possible. So if it's going to be a balanced system, all the spacing between every point that it's traveling through must be equidistant as well. And there's
Well,
only one
it's
shape that works.
that would be, in that scenario, the spacing between the points would be equidistant, but the spacing between the exterior points and the center will not be the same anymore. Because in this shape, in the vector equilibrium, these distances from these outer edges to these inner edges, these are the same length.
Mm-hmm.
But if you go to the icosahedral, these inner edges, they shrink in order to accommodate that shape. So in that sense, then from outside to inside, it's not balanced anymore.
But there is geometry that is balanced, and that is the 64 tetrahedron grid. And that's the mathematically, that's the only one that works. Balance for the equation of expansion and contraction, where the expansive field is equal to the contractive field in vector field strength. Well, no, because the plasma is a dual field system, so it would apply to the plasma as well.
Well, when you go to the smallest, from the smallest to the largest, you cannot expand radially. You have to go through torsion. You have to twist as you're going from your smallest to the largest state. So I don't know if Nassim is considering that or he's just considering radial expansion, because in these geometries you cannot just expand radially.
Well, he's the only one I know of who's actually putting torsion into the mathematics.
And that's sort of his claim to fame in a way.
Pretty
That's
much.
the part that Einstein forgot. Well, so how does this relate in terms of plasma? How can we get a handle on this in terms of number one, maggrav fields, and number two, plasma?
Well, in the macro, I don't think it really is going to make a lot of difference in the macro, because the volume of fields that we're dealing with is incredibly massive. If we could come up with some way that we could balance a macro system to the Planck length, then yeah, we probably wind up with an incredibly efficient system. But to balance a system to within 10 to the minus 39th centimeters is going to be really difficult.
John, what do you think if we create a coil positioning system based on dodecahedron position, when you have 12 times the 540 degree?
I would think there would be an incredibly strong field strength at the focal point. Um, just like if we look at it in electromagnetic terms, if we take a number of electromagnetic coils and focus them into an area, we can create an absolutely massive amount of energy in a very, very tiny space. And this would probably hold true to the plasma as well. It'd be a way to amplify that plasma into near infinite quantities.
Would a 540 degree, would that indicate maybe a coil and a half instead of one 360 degree coil? Can we coil it back around on itself so that it's more than just a one 360 degree coil? It actually becomes a spiral, a partial spiral, and have 12 of those focused at the center.
I'm thinking about having these star formations positioning on all these 12 side one.
How does the 540 degrees come in, do you figure?
It is basically the shape of the dodecahedron, which is the 12-sided.
So that would just be because of having the position of the 12 units would determine your 540 degrees, basically. They'll just be at all the apexes or whatever.
Yeah, it is basically 12 sides and 20 points and 30 edges.
If we could come up with a way to generate a plasma field as an isotropic source, where the plasma field is perfectly spherical, then yeah, I could see that could have some dramatic benefits. But right now, the best we can come up with is a toroid-shaped field and interact the toroids to some extent. I don't know how you would make a perfectly spherical plasma field yet.
It doesn't.
You'd wind up with the flower of life, basically, in pure energy.
It might be possible without being in Earth's conditions, I think.
Yeah, you'd have to be in a very, very stable field condition. But since the plasma is constantly flowing, it's like a river, and there may not be a natural place where that actually occurs.
Well, they found a natural shape out on the space station when they were experimenting with plasmas in the last few years. And it was more or less similar to the saucer shape. It was basically like an almond shape in this a horizontal almond in the middle of their vacuum chamber. And this was a void area that the particles would not go into.
Just to interrupt, Robert, put your coils on the triangles, not the squares. Triangles are the important part. The squares are just space that needs filling.
Well, we're gonna have
Tell it to the
triangulars, eight triangles and 6 squares. Right, 1, 2, 3, 4. Yeah, 6 square faces and 8 triangular faces, I think. Yep.
And if that was to create toroidal fields around those, yeah, right in the center of that, there's going to be a focal point that would be just incredible amount of energy.
There's a popular reactor that uses that I brought up in one of the last workshops. Let me think. I'll get a picture of it. It's called the Polywell. Remember anybody remember the Polywell reactor?
Yeah.
I'll get a picture of it here just a minute if I can find that window.
Rotate that.
Have to do is go small on that for a minute.
Robert, can you allow me to share one image with everyone?
Sure. Let me stop.
Ah, there it is. Perfect. Okay, so it's good to see these platonic solids that we've been speaking of and not knowing exactly
and the
what you mean.
Fifth one is the one which basically was a secret shape, because that represented the universe. And just recently, based on new researches, they find out that this really have to do something about the shape of the universe. But for a long time, Platon and his students was considered these five shape is basically are the shapes.
Well, it's interesting. They call it ether. And I mean, the ether's been spoken of by everyone from Nikola Tesla to a lot of the ancient alchemists and that kind of thing. And
Yes.
Even now, we consider, that there could be an actual material or substance that could be an ether that permeates everything. And if it was, it would have to be that shape in order to interconnect completely with all the other particles, essentially. Because the other shapes don't have the perfect connection that you were mentioning and so on. So you were saying that water, you were mentioning water is normally the icosahedron? Is that
Yes,
right?
this is the representations of water in Platonic solids.
And in our body, it becomes the dodecahedron. Is that
In
right?
hexahedron shape, this is how the molecule is basically forming once they're going into a cell, human body cells, or any plants or animals.
Oh, okay.
And the human body use inner energy, qi in the Chinese language, to order to form and shape the molecules in a perfect structure. This is the only way the water can absorb.
Okay. What else would you like to say about that?
I taking off the sharing, and thank you so much.
Okay, that's great. That's good to be able to see that. I've got a. Where to go here? Here we go. Let me share this. Now we just had that picture of the circles that we can show again in a minute, but let me just show this. Oops, let me get it over there first. And I think I have to resume share or something. Let me see. New share. Let's try that. Can you guys see that share? I'm not sure if you see it or not.
Yeah, it's coming through.
Okay. So this is out of Wikipedia, and it's it's called Polywell. I haven't actually been to this page yet, but I just looked it up. It's a branch of fusion research known as inertial electrostatic confinement. Uses an electric field to heat the ions to fusion conditions. Uses an electric field, okay? So basically they're trapping electrons which attract positive ions, and the ions accelerate toward the center and so on. It's a standard sort of procedure. And people make their homemade units, making little fusers that actually work with fusion. They don't give off more than they put in, but they're working on that. And you can, with a vacuum chamber, come up with these pretty cool fusers. And they have a basic coil arrangement with a vertical coil and a horizontal coil, very much like we were just told by Mr. Keshe. They use a wire cage in that instance to control the electromagnetic field. Sometimes they use three loops, as you can see in the center of that one Farnsworth Hirsch fuser picture there. So, okay, but the one I wanted to show was the polywell here, the MagGrid, not MagGrab, MagGrid. This is a sketch of a MagGrid and a polywell. Okay, so there, whoops. Let's go back to that. So there it is. Geez, it won't let me blow it up. Okay, so I'll just have to, I'll do it another way. There. So this is a MagGrid in a polywell. It's designed by somebody here. That's you can see the specs on it. It's from Wikipedia, so it's a Commons picture. But you can see the rings. Okay, so we have 1, 2, 3, 4, 5, 6 rings in this case, which is our magic number that we were talking about earlier in terms of hex. And this is, they put, these are, in the versions I've seen, these are stainless steel tubes that they use. And inside the stainless steel tubes are copper wire. It's full of electrical copper wire inside these tubes. And they go to their, you know, high energy electrical system in order to create the magnetic fields to contain this plasma. Let me see if I can get out of here. Oh, there's a nice. That's interesting. They have this a picture of the cusps inside the polywell. The line cusp runs along the seam between the two electromagnetics. The funny cusp, they call it funny cusp, is the cusp between the three magnets running along the corners, and the point cusp lies in the middle of one electromagnet. The point cusp, funny cusp.
I don't think we're seeing the picture of the funny cusp. Are
Oh.
you planning on doing that?
Okay. Let me make sure that I'm sharing correctly here. And I'll just try to magnify that. Can you see that now?
No, we're still back with the polywell.
Okay, let me see what's going on there. Thank you. Let's start a new share. Maybe that's the best way to do it. Can you see that?
Yes, I can see that.
Okay, good.
The line cusp is just like the polywell.
Right, right. So they have these three different cusps, they call it. I guess that's where you would have weaknesses and or strengths of the electromagnets. But one's called a funny cusp, but one runs diagonal through these units. And the line cusp is just a straight one between the electromagnets, and the point cusp running through. Let's see a little more about that. Well, they call it a free boundary plasma, interesting enough, and it's a MagGrid. So it's a diamagnetic plasma. It rejects the external fields. Interesting. So
when Robert was drawing on the quads and was putting the toroid on the quads. He would have 6 of them. And I believe John said, we'll put them on the triangles. If you were going to put them on the triangles, they'd have to be smaller. So if you put them on both, you'd have smaller on the triangle and larger on the quads.
Right, that's a good point. That seems like a good way to control things somehow, and you have 2 fields then, which is more correct than to me than what they're trying to do. See, you see this picture of the path of the electron, and this is a single electron motion inside this polywell. So basically, they have a hard time confining it because the thing wants to squirt all over the place. So maybe with what you just said, Denny, would be a way of confining. Maybe we aren't confining electrons in the same way, but maybe we're working with plasma in a different manner than these guys are. Sorry, let's go back to. Do you want to go back to your screen share on that, Robert?
I'm building it right now. Let me see.
Okay. Of course you are. That's great. Let me stop my screen share and allow some reality into it here.
Can you hear me better now, Rick?
Yes, way good.
All right, sorry about that. I guess my new headphones didn't work very well. Mr. Keshe said that we could enclose our spaceship after we had it built by placing a nano-coated wire around it. And if we can control that field with it, can we not control the fields coming out of the plasma generators with nano-coated wire as well?
I don't see why not.
Yep, that's one way that plasma gets transferred and balanced between the old rotating reactor assemblies. Was with a nano-coated wire, just sort of loosely attached to each reactor, allows that balancing to take place. And Mr. Keshe uses nano-coated wire around his some of his equipment to keep stray fields from coming in and that sort of thing too. Okay, so we've got the rings here. Now you're going to put them on the square ends. Okay. Now, I also note that just as I'm looking at this, excuse me, that we have a split ring, right? It's not a complete ring. And I'm wondering what some opinions are on that, because the split ring as an electronic component works completely different than a complete ring. You can have a toroid as an electronic component with windings around it, and it works a certain way as a transformer or as a choke and so on. But you can also have a split ring, and it acts as a capacitor, essentially, because it resonates. A split ring resonates, where a complete ring has to be resonated. A split ring is self-resonating, put it that way.
I didn't quite follow, but
okay. Well,
the thing of it is, I'm trying to relate it to the capacitor battery. And I think that's where I kind of got confused. I had my mind on 2 different things.
I'm wondering if the split plasma ring would resonate the same as a split toroid.
That's what I think, and that's what I think might be an important function of it. I don't think we're trying to get it to go right around the circle like a racetrack. Although it's tempting to think of it that way, like, wouldn't that be a natural way, and you just add energy to it until it reaches a certain point and it either lights up or heats up or gives you what you want, and it just keeps adding to it and adding to it, and you can take away from it anytime you wish, kind of thing. As opposed to the
plasma ring modulator, when you're dealing with infinite energies, scares the snot out of me.
yes, true. Is you know, you had to take a hammer to it to shut it down, or what, you know? And if you tried to take a hammer to it, you get the hammer back in your face twice as hard as you tried to hammer it or something, you know. So yeah, it's a bit of a tricky
Pretty
deal.
clever how it takes you the effort. It's like you're really working hard to put that little blue ring on that triangle.
Well, it's it's hard work doing computer graphics like this. It's true. A lot of wrist work. It's almost as much as doing it in reality. If you had that cube in front of you and had to put it on there, it would actually be probably less physical moves that you would have to do.
Well, in this case here, if you were doing tubes, you would put an inner tube inside. In other words, so you could have your gravitational and your magnetical.
Well, certainly that little blue tube would fit in sort of vertically in between those bigger tubes there too, and fill in that space.
I'm saying inside the gray tube, you would have another inner tube.
Right. You mean in the same plane as that gray tube, or would it be
inside
90 degrees to it though?
Inside of it.
90 degrees to it, or
same? You'd have a double tube.
Yeah.
Inserted into it.
Right. Yeah. Oh, inside of it. I got you. Right. Yes. Okay. I was thinking
so that you could have your magnetical and your gravitational at the same time. In other words, it's like those capillary tubes where we're making them and we're putting one inside the other to get the gravitational and the magnetical without having to turn coils.
Actually, the little ones fit just perfectly the size that we have for the...
By coincidence, eh? So,
It's inside the red when the blue fits inside the red as far as being a double like our stacker units are.
Yeah, it would also fit inside the pyramid created by the red circle there as well. It could go right up inside there as a sort of a booster coil. This looks starting to look like something out of Star Wars here now. The Death Star. Oh no, we've created the Death Star. No, we'll call it the Life Star. It goes around and gives life to everyone. How would that be? But finally, we have the counteraction to the Death Star. We have the Keshe Light Star. It gives off energy and provides life and happiness to everyone. That would be cool. I wonder if there'd be a lot of people complaining about it, though. They would not put up with that sort of thing.
Are you equating this with like a star formation? And you're going to put your magnetical and gravitational into each one of these coils, and how to feed it from one coil to the next, like you do in the stacker unit. Is that where you guys are headed on this?
I think this is just a thought exercise, actually.
And now that you thought of it, I think we could probably add it, but it might take a little more from Robert to have to suddenly add coils, although he could probably pull it out of his coil arrangement thing. But this is sort of just a basic thing to think about here.
Well, Rick, when you're using the tubes and you have one tube inside the other tube, like an inner tube, then do you need to make coils around it? Are the actual tube acting like coils?
Well, that's a really good question. I was pondering that earlier today, in fact, and thinking, what do the coils actually do? like normally in a coil, wire coil, we call it in electrical theory an inductor, and each coil induces a magnetic field. And when they're, like any wire has a magnetic field around it, so when they're coiled, it creates a certain kind of magnetic field, a solenoid type magnetic field, which goes through the center of the coil, essentially. And there's very little field outside the coil. So, in that sense, what would be the purpose of that coil? Well, essentially, it's creating a magnetic field that might be part of the guiding system for the plasma. Definitely, the field will affect the plasma or give it a direction at least, and possibly a push. And so I'm thinking, well, a tube. What would a tube do? Well, a tube tends to be, it doesn't have the gradient magnetic field around the wires. It has more of a constant magnetic field, but it still has a similar type of magnetic field. And it might be that a certain type of electrical pulse could give it the equivalent or better effect than having the coils, I was thinking. But generally, if you have a tube, you're not creating the same gradient of magnetic field from the same electricity, let's say. So in just purely from an electrical point of view and not a plasma point of view, then those particular magnetic fields are important to have a coil for magnetic fields, but we're not dealing with magnetic fields. Go ahead, sorry. Was that Armin? No, who is that? Okay, never mind. Okay, so
You'll get it. You notice when you tighten up your when you tighten up your coils, when you wind them really tight, they look very much like tubes.
yes, right, exactly. So, and in that sense, if the wires were bare and really tight together and you put electricity through them and they weren't nano-coated, then it would act as a tube. It would be like a short circuit, and you wouldn't get the same magnetic field through it as if all the wires were slightly separated, or generally what they do is put a coating of varnish on them, and that separates them electrically so they don't arc out and melt between each other and that kind of thing. Or generally they wouldn't melt, but they could make a connection, and that makes it so you don't have the magnetic field in that part as strong as having individual wires. So, but what does that do? Because we have everything's nano-coated, and we're not dealing with straight magnetic fields in the sense of creating them with the electricity. We're using the coils, the nano-coated coils, as Armin was saying earlier, as a more or less showing the plasma where to flow. Here, go this way. It's the easiest, the path of least resistance for you. And so, wouldn't a nano-coated tube do a similar thing? It would direct the plasma, and if we had an electrical gradient through that tube, whatever that is, by putting a load on one side, then it should direct the plasma through the tube. And the number one rule of creating a plasma and keeping it, or not creating a plasma, but maintaining a plasma, not having it disappear immediately, is to have a surface that the plasma sees and is repelled by, rather than attracted to and dissolved in, or instantly lost. So to keep the plasma going, we'd want to have a nano-coated copper surface with the correct nano-coating will repel a plasma. We could use other means as well, like gold nanotubes works really well for diamagnetic surface. Sorry, go ahead there. Denny, you were going to say something.
Well, I'm a little bit confused how you could make a split capacitor / battery, have it nano-coated and coated with GaNs, and out comes the magnetical, and you're sending it to the to your coil, your plasma coils, whether they're perpendicular or not, and you run it in. And when you're done with that, you're creating plasma. And why do you need a capacitor / battery to do that? Why all of a sudden now you got your plasma concentrated enough to give it the boost to go into that ring so that the ring then contains the free plasma? Is that the principle behind it?
The way I understand it, it's what you could call the tickle factor. Let me just make sure my mic's on here.
Yep.
My other mic, the mic number 2. Yeah, that'd be like a tickle factor. In other words, to introduce a pulse into the a variation of the fields in the core. That's the core wire, the core the core of the call it a reactor, but it's a power unit or coils, and well, basically to create it at the core, to create that free plasma there that can be picked up from it. It needs to be tickled though from the inside out in order to what exactly? What exactly is going on there?
So you're tickling it with the battery.
That's the way I understand it. It has to be a bit of an AC voltage, the way I understand it, and that's why you need a plasma battery. Apparently,
And it's all nano-coated. It's all hit with the GaNs. You're trying to
avoid the
escape away from
physicality.
trying to escape the material. I mean, the physicality,
Mm-hmm.
and have it all plasma,
Mm-hmm.
even your frame.
Mm-hmm.
So
you were saying you were confused, but then you just went ahead and pretty much laid it out what we need to do there.
Why I was confused is I'm saying all of a sudden you got to flow through the battery, which right now has been simplified to 4 tubes. If the middle one can be a tube too, but 4 coils, straight coils with one running through it, and all it is nano-coated and GaNs, and it doesn't need to have the aluminum and the group on the aluminum doesn't have to need to be pasted. It's just simple 4 straightaway coils, one inside the other.
Yes, good point. And I also considered tubes inside of each other that way with the GaNs.
Let me show you one thing.
Is that Armin? Hi, Armin.
Okay, do you want to screen share, Armin?
Yes, no, I wanna on a video.
Video? Okay.
You can see it.
Yes.
I'll show you very simple construction. You can expand on it. Look, you can see?
Yes, you can see well there.
Okay. All the connections that we do, the twisting, I think, you know, we can do it differently. It's very easy. It's plug systems. If you can see, I can just easily disconnect.
Nice. Now, is that brass wire you're using there, or is that?
This is the capacitor.
Oh, there we go.
Look, you don't need to roll it with the paper or anything. You just have to understand what I'm going to show it to you. Here. This is copper, and this is aluminum and brass. Just wrap it on each other. It's a potential difference that you are wrapping it. Okay, you nano-coated this like that. After you nano-coat it, you know, just put it back together.
Excuse me, Armin. You're saying to nanocoat the unit, and then put it the nano-coated parts on top of the already nano-coated wire.
You can just leave it open like this.
But everything's nano-coated, right?
Yeah, and everything is nano-coated.
Okay. Yeah.
Guarantee already in a matter state, but it's in nano-coated.
Yeah.
All three, and lock it up.
Okay, and is that would that be considered to be an adjustable? Is it adjustable?
And then and then when you want to connect here, you just connect one. It's all nano-coated. You can nano-coat all this together. After then, you can apply your GANs. Look, we do all the connections, let's say twisting it with each other wires, you know, very easy and very simple. If I have the same diameter, you know, winded this, even you can do it a little bit longer in. It's not going to affect. And then you can right away connect another end.
That's very good because I was trying to use capillary tubes.
Right, that's what I was just going to mention. That you brought that up before, Denny, and capillary tubes were sounding like a pretty good idea, and they still might be in a way. But this is pretty slick, actually. I like the way that this works, and it's so easy to remove and so on.
Easier and cheaper.
Mm-hmm.
You know, this is different. This is all. It's nano-coated.
See, there we go.
You can put copper. You can put, you know, yeah. I did two different. See, it's coming out. I'm just taking magnetically out, but it's tightly packed. All the metals in. It's winding with the coils. Why? Then, if I apply GANs, it will stay on it. Now you have three different potentials, you know, that you can deal with. Yeah, here, you just slide in. Everything slides in, but it doubles in here. I just don't want to take it apart. Hold it. Yeah. Look, you can wind all kinds of, you know, coils in there. Different, tiny, whatever. Because they are not coated, now you have plasma. You have a gradients of the plasma because it's different materials. Yes, you can try it differently too. So you're asking, you know, because the way they are making these capacitors, it's crazy, you know.
Armin, do you still expect a book?
And the connections here, yeah, I can, and it's perfectly, it's gonna be in frame, so it's very easy to work with. You just put it, and you can nano-coat everything together in one piece. But if you need to change, you can change right away.
Likewise, in the stacker unit, you can use those little.
You don't waste. You don't do anything.
Yeah.
It's your connection.
Nice and pretty.
You can stack it on. You know, you can stack it. Different variation of battery system, stronger. You know, but the connections, you know, guys, you know, if you want to connect, let's say from your upper unit to, you know, bottom unit, the ends, which is coming out, you can do this kind of springs that it's flexible and it stays on.
Armin, do you still expect a voltage reading on the batteries that you're making there? Because I tried the one with the four, the center wire and then the 3 outside coils and got a very low voltage reading. It was in the millivolts. But when I make the regular batteries with the same GaNs, I didn't put any paper, anything except for GaNs on those batteries. And then the ones that I make with the paper and the aluminum foil around it, I actually get a reading of right around 1 volt, like 0.8, something like that. Did I do something wrong?
No, actually, what you have aluminum?
I have the wire that are in the wires that are in the battery are all copper. I don't have any other wires right now. I'm waiting to be able to afford them.
Well, that'd be the difference there. You need to have more of a potential difference in your wires, perhaps, eh, Armin? What do you
You
think?
have potential difference. This is glass. Look.
Right. I mean,
everything
in his, he said he has only copper. So
yeah.
if you
You
had,
have three over here. You have brass. One slides into another here. This brass, I can go outside copper, not inside copper. Yeah. I can even fit this back on. Now I can wrap it another coil and take it out. So many ways to do it.
Okay, yeah, I was hoping that the GaNs was providing the gradients for me, I guess. Maybe I'll use aluminum on the outside of it. Or...
You have to have a little bit caustic and a little bit of sugar inside in your mixture. Yeah.
On these different wires, when people do vaping, you can purchase titanium wire, you can purchase nickel wire at different sizes, the 20 gauge, 22 gauge. And so they come in a little roll and they're fairly inexpensive. And when I got a 50-foot roll of nickel and a 10-foot roll of titanium, and they're fairly inexpensive. So that can give you a variant, and it's easier to find that kind of wire. You can go to a vaping store, you know, people, instead of smoke, they vape.
Oh, yeah, okay. And they have titanium and nickel, you said?
Yeah, they have several kinds.
Okay, great. All right, thanks, Danny.
Thank you, Danny. Okay, maybe we could get back to our picture of
how many of those small circles are there on that? Robert, what did you call that? I got to write it down because that's not something that comes natural to me.
This one, I called it polywell based on what Rick was showing, but then we added these blue coils. So this is a polywell, maybe.
Well, the actual solid, geometric solid. What did you?
Oh, this one is the vector equilibrium.
Vector equilibrium. Okay, and John was saying, well, it's not quite the vector equilibrium that he knows.
Yeah, this is, you got to turn this off. Turn this off the screen. This is a copyright. Buckminster Fuller. Cannot use that, sorry.
Okay. All right. So how many of these little blue circles do we have on that vector equilibrium?
The blues are going to be 8. Like 4 on the top here. Let me see. So 4 on the top from the, you can see from the top, and then 4 from the bottom. So that's 8 of those, and 6 of the red ones. So if you think about it, if the blues are the gravitational and the reds are the magnetic, then we're going to have more gravitational but smaller diameter coils, and 6 magnetic but larger diameters, so maybe they equalize each other. I don't know.
Well, I think you would want, if you had this kind of thing, you would want one of them to be the capacitor batteries and the other one to be the plasma generators. So it could be a complete unit.
You could put the capacitors across 2 coils, maybe across these vertexes.
Yeah, I don't think that it matters when you're making a capacitive battery that whether it's a straight stick or a donut.
Well, I don't know. The capacitor itself is going to have a fields, so it may somehow interfere with the overall fields here if it's close enough. So the positioning of the capacitor or battery coils would have to be thought out also.
It seems those vertexes there are important. If that's how the energy flows normally in that shape you were saying along those lines, then the vertex with where everything meets
it's
might be important.
It's where the energy sort of changes direction.
Right. So that would be, to me, a place where a capacitor should be, or the battery. That's where you have take advantage of a change in direction and direct it.
Yeah, I think.
So if you knew it was flowing along a certain line, or wanted it to flow along a certain line, you'd have an in and out of your capacitor at that point.
Well,
literally at that point.
You got to remember, you got these hexagonal paths. Let's say, so one would be going across this edge and around so you would have an hexagon, equatorial. Let's say you have an hexagon in the equator here, and then you have, if you follow these triangular edges, this triangle has 3 hexagons going on its edges. So then you have, let's say, one energy train going across this hexagon and another one crossing it at this hexagon. So you have two, I guess, trains crossing each other at these vertexes. Almost, well, not 90, but like 60-degree crossing.
Well, at a train crossing is where you find lights. So it makes sense. Maybe that's where the light would squish out. Or that's also, if it's a train crossing in effect, that's where you control the train by putting up barriers. Or, in this case, maybe a plasma battery capacitor would be appropriate. I don't know. It's a interesting structure. It's definitely a lot of
Well,
work with
this
14 coils.
actually I have made models of this with magnets, and in order to make all space filling, you couldn't do with just the vector equilibrium. You need an octahedron also. So one vector equilibrium and one octahedron would fill all space. And if you make these if you assemble a bunch of these with octahedra, you start seeing very interesting patterns. I think one of these days I'll show you guys those magnetic assemblies.
So what if the octahedra was inside of this structure, for example? Would that not give two different field interactions, two different types of dimensions almost?
The octahedron and vector equilibrium are the opposite ends of compression and expansion.
That's why I would think that it would be good to have one inside the other as a means of control. Essentially, then you have the gravitational inside of a magnetical.
Well, you could have, I think each vector equilibrium has 8 octahedrons around it to fill up the spaces that you get by assembling the vector equilibria together. You end up with spaces which are in the shape of octahedra. And when the whole system twists and goes through torsion, the octahedra start expanding and becoming vector equilibria, while the vector equilibria compress and become octahedra. So the whole system pulses from one with all the vector equilibria compressing to octahedra, and all the octahedra expanding at the same time to become vector equilibria. And that in between those states, you get the icosahedral shape.
Do you have a visual of that in terms of, is that something that could actually be created as a 3D animation in your mind? I know that it seems difficult.
Yeah, I've seen.
But it's more than just what we see here, expanding and contracting. It would have a different look to it than just these rings going in and out and so on, right?
No, what happens is you see this triangular face.
Mm-hmm.
If you start rotating it, let's say clockwise, the square faces are gonna become trapezoids, and you're gonna have two equilateral. So like these two ends, this top and bottom ends, are gonna move away, while these two side points are gonna come towards each other. And at one point, the distance between these side points is going to be equal to this edge length. So you end up with two triangles. So the square face is going to become two triangular faces, while this triangular face rotates. So this vector equilibrium is going to become an icosahedron. And then it's going to continue, this rotation is going to continue, and the icosahedron is going to compress into an octahedron. And at the octahedral stage, it's going to have all the energy that was within this larger shape compressed into that smaller shape. So I'm kind of working on a theory as to what neutron and neutrino are and what proton and electron are, sort of the whole transformation from one to the other.
It also sounds a lot like GANs in terms of
yeah, I think it's
this compressibility and able to expand and so on. Maybe it's expanding and contracting is the actual vibration of the thing.
yeah, so the whole universe is in constant expansion, contraction through torsion, through spinning, and it's what happens is as this triangle twists, let's say clockwise, it comes to the octahedral stage, then it twists counterclockwise. So it starts expanding. So that could be the magnetic half of the cycle, sort of, while the contraction as this triangle rotates to an octahedron form is the gravitational contraction half of the cycle. So the whole universe is sort of oscillating between gravitational and magnetic phases. And remember, at the same time, while this vector equilibrium is contracting, an octahedron next to this that's filling the space between these vector equilibriums is expanding. So you have a gravitational collapse happening here where there's I don't know if it's magnetic or radiational expansion happening in this location. And this is all throughout the space. Energy pulsations going on. But because this is a vector equilibrium, the energy flow through this space, sort of through the system, is not hindered. Both going through the inside of the system and across the faces of the system, the energy flows freely. So we don't detect it. It's invisible to us. But as soon as it reaches the icosahedral stage, the energy kind of momentarily gets trapped in the icosahedral shape form, sort of crystallizes for a second, and that sort of appears as a matter. I don't know, that's kind of my thinking about it. I could be wrong, but it's a line of thought I'm following right now.
Well, thank you. That's interesting. Go ahead.
Is the goal to trap the plasma in the middle, right?
I don't know if that's the goal, but that will be the resultant of having all these fields present that should create a combined field somewhere in the center. And that would be free plasma or amplified plasma field or something. I don't know.
Makes sense.
Okay, because I'm thinking of enclosing one of my plasma reactors, the 3 stackers, in a similar formation of nano coils like that in order to contain the plasma that it is creating. So I wouldn't GAN coils necessarily. I'm thinking about that in order to contain it. I don't know.
I don't know if containing is the right thought. If it's plasma and it can go through matter.
But if you can
Would
create,
concentrating be a more appropriate term, where you concentrate it in a very specific spot and then you guide it towards a certain direction?
I guess it would be sort of create a higher potential at that location while the surrounding is at lower potential. So there would be a flow from center outwards, maybe.
Okay, that being the case, I was just looking up something. In this octahedron, we are looking at, okay, layman's terms, we're looking at triangles that are going inward. What if we look at triangles that are going outward from the inside, something like a stellated dodecahedron? Would that be an emissions kind of a representation of plasma? That means from a source where the plasma is being emitted out in a certain way, where that is being directed out in a certain way.
That's the way I'm thinking of this too, is to contain, or, like if you were to take one of those rings off, you know where the plasma is going to go, and you can direct it in that way, or even as a control device, possibly, using this to take off one side, you would have, quite a few different ways of direction.
Yeah, because when I look at the diagram of the common small stellated or the great stellated dodecahedron, that's what it appears to be. It appears to be an emissive characteristic from the center, and it's in a star formation that's coming outwards.
Yes, I understand.
Yeah, I think when you create the field interference in the center, it's going to have its own gravitational and magnetic levels in a balance in order to stay there at that high intensity. I guess the gravitational would have to be slightly more than the magnetic. And in order for it to radiate out, sort of to expand out, the magnetic would have to increase more than the gravitational for it to start expanding outwards.
Right. So we can think about it in the same way that a planet does it. For example, an erupting volcano from the surface of a planet.
Mm-hmm.
So in that case, I think if I remember correctly, in instances of volcanic eruptions, a magnetic field disturbance is recorded in that vicinity of the magnetosphere.
Right.
And so just even by touching one of these coils should interrupt the field, or not interrupt, but change the field enough to possibly, if you were to learn the system, provide like a directional or a way of directing plasma, I would have a question.
You're kind of fading out. We couldn't hear the last part.
I apologize. I was just saying that even just touching the coils in a certain place should change the field enough to possibly control the plasma in a way.
Yeah, if you can control the intensity of the magnetic and the gravitational, you could reduce the gravitational fields in the coils. That would increase the magnetic, and the plasma would, I guess, expand. The center free plasma would expand, and if you reduce the gravitational or increase the gravitational and reduce the magnetic, that should compress the center plasma field. I get, I'm just thinking out loud. So if you could control the strength of these coil fields, you could control the inner plasma. And also if you could control them in a way that the magnetic on the, say, left side was more or less compared to these other ones, you could maybe shift it in space. And if you could, have a circuit that controlled the fields of these coils, you could maybe create a rotational movement of that plasma inside. So you could manipulate it in space, position, and rotation.
Right, because it would be a perfectly balanced model at first. Everything would be almost perfectly balanced, like you guys were saying at first. And so now to take that and interrupt one of those, you would be able to almost choose what you wanted to do, and where you interrupt it, you may be able to decide where that takes you, or where that takes the plasma.
Yeah, you could play with the plasma by playing with the fields of these coils. And I guess to create lift, you would increase this lower half, create a more magnetic field down in this lower half versus the upper half, or vice versa, to give it the whole system a directional motion, maybe. I don't know, I'm just thinking, would the plasma, if you move the plasma, would it move the whole system with it?
Well, that's an interesting concept. And we also have to think about the idea that the plasma will not necessarily be contained within this system. This is only the control part of the system in a way, or generation and control. Plasma field could be, meters outside of this system. And in the case of a spaceship, supply for the plasma, and that would be the situation. So
that's true. Yeah.
With my spaceship star formation, if I were to hook a magnetical and a gravitational up to this and have that inside of that field, then that would add to and be contained by the overpowering plasma of the star formation.
So we could control, the ship.
Yeah, because I'm almost there with the star formation, and I'm thinking this might be a way for control of that.
So you're saying having the star formation inside of this formation?
No, having this formation inside of the star formation.
Okay. Mm-hmm.
Like with smaller coils, something I could even hold, or set on something like a box or something. I don't know what you would do with plasma to make a shelf or something, but I guess time will tell.
Hang it on a nano-coated thread, perhaps.
Yes, absolutely. Yeah, I've got some nano-coated plastic that I'm playing with right now, so we'll see how that works out. Quite a bit of it.
Or you could take some twine, some natural fibers, soak them in a 80-20 mix of distilled water to GANs, and then the twine will hold some GANs in it, and you could use that as well.
Yes, absolutely. Yeah, it's already nano if it's natural, right? So
that's right. And because it has GANs on it, there's going to be a plasmatic flow as well.
Absolutely. And then even if it were on a string, even pulling one string to make it move within inside of the other. Sorry. But yeah, to move it, make it move within the other plasmatic field may I'm getting excited about that.
That's starting to look pretty good, Robert. Yeah, it's starting to look pretty good there, Robert. It's just about viable now. We can almost hook a few wires on and she's ready to go, I think. Whoa. It's got a nice style to it as well. I like
crystal structure.
Yeah,
sort of.
where do you sit is the one problem. And you become as crystal yourself, and you're in the center then.
If the field is all around it, you could stand outside of it, and if you're in the field,
yeah,
you go where it goes.
Mm-hmm. And it may probably well be a crystal in the center. That is the way that this operates. I have a strange feeling that crystal will be in the center of our spaceship reactor somehow.
If you're thinking of using the craft, would you want the top open to kind of form the bell shape rather than being compressed in on itself if you were to be inside of it?
Yeah, it would be a different structure shape probably. Mr. Keshe talked about making the floor first, for example, in the spaceship. So it tends to be relatively flat, and then the dome part goes over with the fourth and fifth reactors, like help control the dome part. So that might be something we'd have to alter this design in certain ways. But this looks like, to me, more like a reactor core, like a plasma general containment, more than perhaps more than creating a field for a craft. But I don't know. It's all kind of conjecture in a way here. We're just playing with images, but we're also playing with our idea of what we think plasma is and how it is controlled and what it will look like and how possible systems could look like and operate. And this is definitely, I mean, if you look at the center of that, everything points to the center. And if that can be the emotional center, you might say, of our system, and that will be the point that we connect with in our physicality, and maybe that can be controlled through those rings or from our own thoughts and feelings and so on.
Definitely a good health unit.
Be nice to have that sort of beach ball size and follow you around and provide you with everything you need.
Like a balloon on a string, Nick?
Yeah, basically a balloon on a string without the string. So it'd be like the drones they have now that follow you around. You can control them with your iPhone, and they follow you and take your picture at the same time, a few feet above your head. So this could be a similar unit. It seems like an intelligent unit that would be almost not a pet, but a friendly companion, you might say, as you go through life.
See, in this position, it looks like a cube.
Mm-hmm.
Square. But if you look at it from a different view, you see the hexagonal equator and all these lines. If you follow them, you see
Mm-hmm.
This line goes through the bottom. That's another hexagon. This line going through the bottom there, there. That's a hexagon.
It's like a circumference.
So you have four hexagons in this system. And those are the paths of least resistance for the energy transfer flow.
I'd be tempted to coat each one of them with different GANs probably. It might throw off the balance, but you could direct the intention in a different way.
Yeah, I guess it's what you want to do with the plasma. If you want it to give you energy, then you would create unbalanced system to make it flow from high to low potential. So you could do different materials, different gases to create that imbalance.
So it's interesting. Like this is a. Yeah, look at that. That's a nice close up. I find the idea of these rings quite intriguing. I'm wondering if they can be made as rings or tubes rather than coils. Or maybe have a coil within a tube. Go ahead.
Have you made a model of that battery capacitor that he was talking about yet, Robert?
Armin was talking about? No, I saw it. He showed it to me, but I haven't had time to make
the
it.
the one Mr. Keshe was talking about in the 94th Knowledge Seekers Workshop.
The 4 coil one, you mean?
Yeah, the A, B, and C.
Oh yeah.
I haven't seen the 94 yet.
Oh, okay.
I have still to watch that.
Okay, I'll make one up then. Tomorrow I'll send you some pictures. Maybe you can make a 3D model of it.
Yeah, if you can send me a diagram, photo, whatever can help.
Okay, thank you very much.
Let's see, I think, oh, let me see, where is our logo? Alright, did you guys see this one?
Oh,
Very nice.
yeah, beautiful.
Now you'll have people complaining if it's not 144 turns.
Yeah, there'll be people counting them, that's for sure. There's some inner secret they're trying to show here. How many coils are there, Robert?
I don't know. 1, 2,
Okay,
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 turns. And 7 colors? 1, 2, 3, 4, 5, 6, 7. Yeah, 7 times 21.
147.
Mm-hmm. Well, it's right in the magic ballpark, isn't it?
Yep.
Close.
Interesting. So what would be nice would be create a logo with just using the blue circle thing as well. because that's the logo for the Spaceship Institute without the KF and so on. Yeah, that guy. I'm not sure if it should. It'd be nice to have some 3D-ness to it, I think. I'm not sure if that's what we're after, or maybe more like a dish shape. I was thinking more like a bulge on it, like a saucer or something, you know, on its side.
Yeah.
That could be cool.
Well, this shape, I don't know who came up with this and why is it this shape, but this could be a tetrahedron. We can make this tetrahedral, you know, with these 4 outside ones, and this could be the central.
Right, that's what
plasma
it's
field.
indicating, I think. It's got very specific representations that were made. Mr. Keshe sent that information to someone. I'm not clear on who that was.
It came from Iran, I believe. The Iranians gave it to Mr. Keshe as a gift. That
Right,
logo.
yeah, from the university or something. So it's very specific and very important to make it exact and so on, and not, you know, alter it as far as its original dimensions and proportions.
Yeah, but this is, to me, this is the 2D view of a 3D.
Yes, exactly. If you could imagine if you were an alien, and or if this came from an alien civilization and we looked at it with the knowledge we have now, that's exactly what we would start to think. This is a free plasma formation, right? And it's actually in 3 dimensions because of the difference in the size of the spheres. It makes you, you know, automatically have to orientate it a certain way to make it look like the spheres are all the same size. In other words, it's a perspective, artificial perspective on a 2D surface, providing the 3D perspective. And there's probably not a better way to do it than to do it that way, really, showing the connection between all of them. Interesting.
Yeah, I always thought it was a star formation that it was showing.
Yeah.
Yeah, it's a star formation with the center being the free plasma created. But see, we could.
I also see it as it's an actual spaceship in itself. You see the moon shape. It's sort of a moon, but it's not really a moon. It's a very much stretched out moon shape. In the front there, it's actually a force field for the ship as it travels through space, I believe. That's your...
different way you can understand too. It has a hydrogen, nitrogen, carbon, and 2 oxygens.
2 oxygens.
Hydrogen, 2 oxygen, hydrogen, carbon, and
the first one hydrogen, carbon, nitrogen, and 2 oxygen.
What's in the center?
Nitrogen.
Nitrogen in the center. I would think this would be oxygen, hydrogen, carbon, nitrogen. Which one is bigger, carbon or nitrogen?
I think it's carbon.
Nitrogen is bigger. Nitrogen is 14, carbon is 12.
Oh, okay.
And I would think that hydrogen should be in the center. Because it's always in the center of the core. Eh?
Nitrogen divides, right?
Yeah.
Out of nitrogen, it goes oxygen. And hydrogen.
How about carbon, oxygen, hydrogen, and nitrogen as the outside ones, and free plasma in the center?
If you look at it, if it's hydrogen, it's a direction.
So the center
wait a
one.
minute. Say that again, Armin. That
Like hydrogen is a direction. In our universe, you know, hydrogen is a essence. It's everywhere.
So this is hydrogen, the center.
No, the first one, the first smaller one.
This one.
Yeah, smaller. Even the sizes, if you look at it, two bigger sizes are the same, and only these three are different.
well, they're all different sizes though. I don't see any two the same.
Oxygen is bigger. Oxygen would be this.
And Armin was saying there'd be two oxygens rather than two hydrogens. I think, isn't that what you said? Or hydrogen.
Or amino acid. Actually, this one that's what it is.
Well, that's kind of because it's a 2D of a 3D. If we're thinking this is just closer to us, that's why it's bigger. Then it's kind of would be hard to say which one is which because
Next
of
time
the.
we can ask.
Yeah, I think that there'd be lots of different ways to interpret it because it is such an essential image. It's so, core, primordial kind of image, and it makes sense that it would be, the four core spaceship, starship configuration as well for reactors. Lots of different ways to look at it, but it would be nice to get some more input on that from Mr. Keshe. Maybe we can convince him in the workshop tomorrow. So this logo would be good for the KFSSI, which is the teaching arm of the Keshe Foundation. That's not the actual
manufacturing side. It would be better. Coiling.
Right. Well, KFSSI is what Mr. Keshe calls the teaching is, like the online teachings will be KFSSI, as opposed to SSI, the Spaceship Institute, which is a separate entity now. And also the Keshe Foundation is a separate entity. There'll be three separate websites. I'm not sure how manufacturing works in there, Armin. Would manufacturing be under KF or KFSSI or SSI? SSI?
Mm-hmm.
I think we should have a new logo then for SSI without the KF, perhaps. We'll have to ask Mr. Keshe about that. Maybe he can give us some direction. Maybe we can keep this logo on hand and maybe we could have a little discussion with that with Mr. Keshe if he's willing to do that. I'm not sure if he wants to discuss publicly about the logos and that sort of thing. But we do need to clarify with the public about this new thing about separating the three entities.
Yeah, if you can set up a meeting, let me know. We can.
Okay, that's a good idea.
Okay.
Okay.
Anybody else has anything to share? I'll just unshare.
Okay, yes. Any other questions, comments, things to share? What do people have out there?
Well, this is Denny, just a discussion. When Modra showed his system during the Knowledge Seekers workshop, and how Mr. Keshe explained it would be good if you made everything nano-coated plasma, make certain you don't touch make certain you don't, or it would be a tip not to tie the magnetical coil to the frame the same way, to the same frame you tie the gravitational when you're dealing with the perpendicular coils.
Right.
And so, thanks to Madras, it kind of opened that particular thought up, and how you make your frames when you make your stacker or your perpendicular. Anybody else have any comment on that?
On the coils, anybody want to comment?
Oh, sorry about that.
Oh, go
I was
ahead.
thinking, he was using plastic to tie them up, and I've had a little bit of heat coming off my systems. I would think you would want to use nano copper maybe instead. I don't know if it would melt, but you know, it could be a concern if somebody were to overload it, if that's what they're using it for.
Okay, that's a good point. Okay, I just wanted to share something from a website here that I'm just going to show the live website, which I believe I'm allowed to do. And let me see here, get my things together. Okay, let's see here. This is from a website called militarybest.com, and they have military insignia. And I just happened to notice when I was looking through some icons in search in Google that this icon, this shape turned up. And I thought that was quite interesting. This is for the Navy Aviation. Seems like a contradiction in terms in itself, but Navy Aviation Electronic Technician. It's a ball cap pin. And I thought, well, in relation to last plasma reactor group, I was showing the insignia for Toyota cars. And it's, you know, 3 rings. There's a ring around and 2 rings inside, very much like these rings. And I thought, well, that's interesting. And I looked at it really closely, and if you were to see if I can exaggerate it a bit here. If you were to look at it a little more closely, you'll see the 2 rings, and they're more or less interlocking rings. And the peculiar point is, not only do they have wings attached to them, but they have little stars where the intersection is in these rings. And it's funny because I've seen other duplicates and replications of this similar Navy insignia, and they usually have the stars in different places. But in this particular one, it's at the intersection point of these rings. And I'm thinking, well, that's like the intersection or the 2 fields interacting or intersecting and causing light perhaps at those points. It's, you know, similar in a way to Mike Najif is talking about the infinity loop, and where it crosses is where the light tends to happen and so on. So I thought, well, that's pretty neat insignia, and it looks very much like that Toyota emblem, and very much like our new coil systems with the vertical and horizontal coil. So if we can make ours have sprout wings, I think we are on the right track there. So I just thought I'd share that. It's kind of fun. Thank you from the military best people. And okay, anybody else have anything that they'd like to show, or should we wrap it up for today? I'm not hearing a lot of response. I take that as a time to end the show, perhaps.
Sorry, Rick, I had to run back to my phone real quick. Has anybody tried those battery capacitors yet?
Only in my mind so far.
Okay.
There must be someone out there that has, though. Anyone?
I was just wondering if there was someone here that may have done it already.
I was supposed to have built them last week, but because of an inner ear infection, I couldn't do it. I think I will only be able to do it over this weekend. I'll give it a go, and maybe for the next session, I'll share what I found out.
Thank you,
Okay,
Vivek.
yeah, I built them. I haven't had much with them yet. I was gonna maybe see if you could help me to find out why. Just,
what kind of GANs are you using?
It's a mixture.
And you have all copper coils?
Yeah, all copper coils, but I have an aluminum covering over the GANs.
Okay.
It is nano coated to the best of my ability. It's it was heated up and then sprayed with caustic. I figured heating it up may expand the space between the molecules, and then I sprayed it with some caustic. It was thicker aluminum, like a pan, like a cooking pan. So it didn't really eat it up too badly, but it didn't turn completely black either.
Robert, did you see what Armin showed this tonight?
Yeah, I'm gonna definitely try that. I was just wondering why maybe it seems like it works until I connect the one coil coming off of the aluminum back to the negative coil, and this is just electric readings too, so I'm not sure if it really matters coming off of a voltmeter. It goes down about more than half once I connect to the center negative terminal. So I'm not sure if that really matters.
Are you sure everything's nano coated properly as well? You get large resistance on the wires when you do a resistance check on the coating, like on the.
Everything's in the millions.
Right. Yep.
Everything's in the millions of ohms.
That's right. Okay. Well, I think if you create with whoa, there's something different.
Oh yeah, my goodness. It's a monster.
Yeah, this is something that I'm considering in terms of tubing as well.
Nice. It looked like a fist from that one view. You could put it in the Fibonacci sequence and make it like a shellfish almost coming up there.
Well, in a way, it's the what they call the right-hand rule in electrical, where you grab a wire and you wrap your fingers around it, and that's the way the magnetic field goes in that wire. Well, this is like a big fist, like you were saying.
I made 2 of these this week because we were talking about this last.
Yeah.
We were talking about this, and so I made 2 of these.
With the coil and the wires, or just the coiled wires? I mean, sorry, with the tube and wires?
I have a tube.
Right.
With coiled wires wrapped around them.
Yeah, yeah.
And then I placed another one on the inside. But you know, it was difficult to do by hand. And by the time I got done with that, I said, how many of these do I really want to make? Even if they were, I'm going back to the perpendicular. It's so much simpler.
Mm-hmm.
It's, we were talking about this last week, weren't we, Robert? We called this a spherical coil.
Yeah, I think I can adjust this tube inside to make it more or less spherical.
It's very difficult to do it naturally too, but it's pretty nice. So yeah, this could be a pretty good battery. Could be, if plasma could hide in there pretty good.
All right, that's what I wanted to show. If you guys want to wrap it up.
I got one little, I can put my video on, and if Rick will see how you do that. So this little triangular thing is pretty sturdy, and of course I can hang down the perpendicular in between. Of course, as I'm looking at this and I make it better, this is just a quick prototype. Then I was thinking of putting my my battery capacitors onto these things here, and that way I could end up hooking it into my perpendicular coil. Of course, I hang the coil down this way and the other one goes through it. They're just hanging off of it. And this right here is a jumbled mix right there at the top, but you can pretty that pretty easy. So then I thought, that's copper. It's copper. It's, I don't know, it's probably 10. Maybe it's 8 gauge. And so, but I also thought, you know, with this, you could probably build a star formation just out of this, putting your may say making that out of tube and setting this up to where that's all nice and making it circular up here where I don't have it all jumbled together. I made one with the lighter one because I was going to make my my separate small ones, and then to make my star formation, and I was going to make a bigger frame. I think Robert does a triangular. Robert Stubberfield does a triangular hanging system as well. So I just twisted this together for the fun of it. But I think a person could, like you do, Rick, think about it for a while and make it prettier, and even wrap the coils around it and use these for the capacitor batteries. Use the frame for the capacitor batteries instead of hanging them down. And you have one unit. Then I wouldn't mind setting up a star formation inside one of these loops. You know, you could set up the loop itself and put your plasma generators in here, your perpendicular plasma generators in these little holes. Hang them from there if you wanted to.
You have yourself a little cosm of the macrocosm at that point. You could do that on all three and do.
Yeah.
I like the idea of using the frame as part of the structure. That really makes a lot of sense now that you bring it up. You know, it should be part. It's rather than just nano coating the frame and trying to make it not interfere with the plasma. Why not have it be part of the plasma circuit, let's say, and have it form a useful function as part of that circuit? So we want to go with as minimal as possible is probably the best way to go. So if we can maybe that is already the correct shape for plasma because it travels in strange ways. So
So you begin to follow the where the plasma would flow.
Mm-hmm.
Because this is this little piece of paper.
Yeah, let's see your piece of paper there, Denny. Now's a good time to.
Because you're starting to say, here's your entrance up here, and it comes down, and it goes into your gravitational coil, your small gravitational, and it goes around, of course, and this is backwards, and because it's mirrored, I had to flip it over to see how to do it. I think this is.
You might see it backwards in your picture because it's backwards there, but it flips back to normal. Whatever you're seeing is what we see right now.
So that's backwards to you, and this is right for you.
Oh, okay.
Is that right for you on your screen?
I'm not clear on what's left or right
well,
on this.
usually we come down and we start our coils and we twist them around and we make a loop and we come out here and we go back up to the magnetic, gravitational, and it goes. Okay, let me explain that again. So here comes the entrance. It goes around, comes in through here, back through the center of the coil, and now once it comes out of the center coil, it comes back up here to the gravitational, goes around, and it comes through. Once it comes out of that gravitational, so you feed it to the magnetical. All my arrows are showing the direction of the flow of the plasma, and these right.
It's showing correctly over here.
Is it showing okay?
Yeah, it's showing okay.
Yeah, other than I think the coils are in the backwards, the clockwise wound, counterclockwise type coils.
As long as they're
all consistent is the theme. Okay,
otherwise
that's good.
we can do it over here and make it that way.
Okay. That way they're correct.
So once I drew it, I was able to trace it through on the window. So this is like Armand's wires, how he connect them to.
Yeah.
I was using a capillary tube to do it, but Armand's is so much better because you can get a little more. Well, it's not much better. It's just easy. It's you have the material at hand and you don't have to go hunting for capillary tubes, and then you just wind those little coils and stick these two pieces together.
Mm-hmm.
Because I spent half the day trying to figure out if I could do all of this with just one wire. And never, it would come through, and I could.
You can do the magnetical coil, one tube. But you can divide the inner coil like 81 turns, and you can just open up and divide it over there. And you can make it only magnetical. You can do it. So you lose one connection. So you have only two connections to make.
In this case, I have three. One.
Yeah.
3.
So if you do, let's say 144 plus 81. Correct?
Yeah.
And then you open up. You don't cut. You just open up. Count like everyone and open up. And then you can turn inner for gravitational coil. You can put it. The gravitational coil you cannot have that way. So you have to cuts only.
Because once you come out of here, okay, where am I? Once you come out of here, you're starting your magnetical, and it goes all the way around. But because this thing is so backwards, and I have to look at it backwards in a mirror, it begins to confuse me. And so when I'm trying to look at my screen at the same time I'm showing it, okay, so like you're saying, the magnetical is done at the end, and you can poke the gravitational inside it.
Here.
Here, okay. Do you need the screen?
Let's say this is through your outer magnetical coils, one is longer, it's here. Then you have your other coils. Where is it? I have so many.
You get to working on too many projects, you forget where you put all your stuff.
No, it's I already did. Where is it? Okay, anyway, here. If you have your magnetical coil going around to the big one, the bigger gravitational coil, and then you have your smaller gravitational coil, whatever it is, going around here. And then you have your shape. The same thing, but only this connection is together. You just twist it.
Yes. And you don't have to mess with an extra wire.
Yeah. Actually, extra connection.
Extra connection, I mean, too. Because you're going to have to, if you make that connection like you do, by spinning a little smaller coil and sticking the two wires together, that's a pretty clever way of doing it.
It's funny, Rick brought up the counterclockwise, clockwise thing earlier because we've got a whole new group of people trying this because I've been asked that question a whole bunch again recently. So a bunch of people must be going through the same thing we were going through at the time, and they just haven't gotten to the last video yet, or the 86th workshop, or whatever.
There was
Just direct the flow. If you're directing on the right side, just direct it the same way that you add to plasma.
Hi guys, it's Modric.
Hi, Modris.
Hi. I was working on that frame, and actually I thought, we can make from the frame or the battery or the capacitor itself. If I share screen, I can show quickly.
Mm-hmm.
So, example, these ones. It's probably you see wrong, right? Now it's good, yeah.
Yep.
So this is the frame. I use the copper example. So this is the one which goes here, and then there is another one. We can leave it the same one. So, and then this is the another one. Yeah. So you can, when you connect them, you can make, wrap around with the paper with the GANs, and then you connect to that. So you kind of feeding extra. It's like you're feeding back, and you feed extra back to the gravitational. And here they connect again. They most probably the structure have to be perfected, but
I like the
it's
idea.
very easy, Madras, and thanks for showing your stuff last week as well, because it gave us new perspective. And yeah, I did that with this heavy wire. I just put one little U-shaped and another little U-shaped because I wanted, just like you're thinking, I wanted to go ahead and have my my battery connected to my be part of my frame. And as Armin has shown, the different type of battery where you don't have to use the paste and the aluminum foil. Have you tried that yet?
No, not yet.
So as you start to do your drawings and stuff, incorporate that too in your thinking. I would suggest.
Yeah, it's true.
This is a very good idea. This four-legged unit, and even when you're hanging your, let's say you do a star formation, and you do this four-legged unit, you don't.
There was another idea.
You don't have to dome it at the top. You can.
Can I quickly show that part?
Oh yes, go ahead. Show all your stuff.
There was a point where I was thinking, like example, this would be the base which holds. So then you make small hole here, like to connect some kind of wire, and here, and then you basically make
All you have to do is nano coat your bird cage and you're ready to go.
and what I meant, like example, this would be a bigger cage, and now you can hang them on 120 degrees if you like, and you can even move up or down and like more angle to make, so you can kind of play around with this kind of structure. But I was thinking, like, if we use 3 or doesn't matter how many cores we put inside the springs, we can make it like in a cage, which we can make in a huger structure when it's become the star formation. And I was thinking about hanging, because like that we can, move up, down, we can change the angle. Because if you make example this one like that, and you just make the lines where you can move this wire up and down, you can, structure, because Mr. Keshe was saying to make a solid wall, you will have to move it anyway around. And I think it could be the way. And anyway, it's just idea.
It's a good idea. Very good idea. And
remember one thing. Let's say these connections that I should always make the same from the same wire. I said the connection, that coil connections that you are making, try to make it from the same gauge of the wire. Don't, put a thinner wire for the connection.
okay, I don't know quite what you're saying, but when you made those little connectors, those little coils, then you slid the other piece of wire in. You're suggesting that, yes, okay.
Same diameter. So use the same diameter for this kind of connection.
Okay.
You're saying don't use the same diameter? Is that what you said?
Use the same diameter.
Well, those are different. That's a different diameter, though.
That's what I had.
Oh, okay.
This is what I'm showing. I already made this course long time ago.
Okay, so it should be, and should it be copper wire instead of brass, or what do you think about that?
Copper, the same wire. When you connect them.
Right, so it's all the same then.
All the same.
It'd be maybe hard to make a tight coil with that, but it can be done.
Not for capacitors.
Okay, that's good. Yeah, good point there.
Thank you very much for sharing, you guys. Thanks, Modris. Thanks, Armin.
Yes, thank you, everybody. I think I'd like to wrap it up. Well, go ahead. Sorry.
I have a very quick question. Since we were looking at alternative ways of doing the star formation, I actually did a redo of my flower of life. I'll just show it on screen.
Okay.
Okay, this is made from 2 coils. There's a magnetic and gravitational coil in this structure. And what I've done is I've connected this to my stacker unit, and I put it on top of my stacker unit. What I'm trying to achieve here is the same effect that Ali achieved by putting 5 stacker units in a star formation, 2 in the center and 3 around. I've yet to achieve that, and wondering if anyone has any suggestions on how things can be done. So far, what I've done is I've coated this with GANs, the same GANs I use to coat my coils. And I've also put a ping pong ball of GANs right there in the vertical portion of the star formation flower of life. And I've set the whole thing on top of my stacker unit, and I've connected it to the split capacitors of the stacker unit. So the input, that means going into the gravitational coil, comes from the output of the three coils, and the output from the magnetical coil goes back to feed the feedback loop from the stacker from the split capacitor to the bottommost coil. Wondering if anyone has any suggestions on design improvement or something else that I could do to start to see that the same effect that Ali was seeing.
Okay, you created the structure. Now create the flow.
Sorry, say again. I've created the structure now.
Now create the flow of the
Okay.
plasma. If you're gonna do with your batteries, you don't need huge amount of energy to start plasma. This is my thinking.
Okay. In fact, that was what I was planning to do this weekend when I have a chance to make the batteries. What I will do is I will disconnect this from the stacker unit and I will connect the batteries to this instead. And then I'll put the whole thing on top of the stacker unit.
Try it.
Okay. Okay, wait, let me just quickly stop the screen share. I'll bring up another picture. Where is it? Okay. Now, I just want to ask if that ball of GANs that I've placed over there is necessary.
Well, this
Are
is
you trying to fix the plasma flow right there? At that point going up?
Yep. I mean, there's plasma flowing through the whole structure.
Right, but you're trying to enhance it right at the point where it's pushing upwards into the top coil, right?
That's right. So we want a positive positioning upwards so that it levitates or lifts.
Right, okay, I understand. I just wanted to understand what.
Yep. So the thing is, I did not know whether I should put the ball of GANs over there, so I've just put it there in case. But the question is it necessary?
From that, I wouldn't know. Maybe Armin. As far as Armin was talking about the flow, it would seem to me that it wouldn't necessarily matter, but I don't know. Yeah. Maybe he's still on.
That was what I was thinking as well. I also was thinking that maybe I should be creating the gradient effect of the plasma a little bit differently by coating each section of the star formation in this structure with a different combination of GANs. So for example, the center reactor in the center at the base, I would coat with 3 GANSes, CO2, CH3, and copper oxide. Each of the side reactors beside it, I would coat with a combination of 2 of these. And at the top, maybe I coat with only CO2. And that might create a gradient in the structure.
Yeah, I think it's a good idea. And actually, about the middle one, how I see the GANS ball, which we put in the middle, when we're now creating the coils around it, it makes the flow magnetical and gravitational. Now, because of that flow, we don't need the motors anymore, but we need
Right.
the storage, and the GANS is where the energy comes from.
Okay, so you're saying that the GANs, it's okay to leave the GANs balls there.
I would, yes, put where there is the free plasma located. This is my opinion. Maybe someone has another one. And the idea, each ring to coat with different GANs, you have to make, yes, this flow. And otherwise it will find the balance and it stays.
That's right, because right now the GANs coating that I did, I coated with the same GANs for all of the whole structure. So
Yeah.
that's why I think I'm not seeing anything.
Yeah, then
It's
you could do that if you make another set of another 3 of those, and then you make another one weaker, and then they between them will make that flow. But if you want on that one, this is how I see.
Okay. Thank you, Modris.
You're welcome.
Okay, thank you, everybody. I will make the necessary changes over this weekend, and fingers crossed, hopefully we'll have some good news for everyone next week. Thank you.
Okay, may I quickly show the star formation which I've started? It's got the frames like he's talking about as well.
Okay, sure.
Okay, the video's on. Okay, one moment, let me switch. Okay. Okay, so it's basically the copper frames haven't been nano coated yet, and there's only one stack in the middle. But there is 3 batteries going to one, 2 going to another, and 1 going to another. They're all hooked together, gravitational to gravitational, magnetical to magnetical. I just don't have, and this stacker that I've got in there right now is actually going to a gentleman in Pakistan. So as soon as they come to get it, it's going to go there. So I'll have 2 different stackers, but that's basically what I've got. I don't know if there's any comments how I can improve it. I know I'm going to have them all on the same level as well, so I'll have to adjust the frames just a bit.
I see you have all the coils are hanging vertically, we might say.
That's correct, yeah. I've never heard anything that said we couldn't. Therefore, I kind of figured that it wouldn't be a problem. But that's what I'm looking for right now, is if it's...
I'm sorry.
I'm sorry.
What
No,
I
please.
remember that Keshe was saying, they have to be on a line. Maybe they can be vertical or horizontal, but the inner rings, when they go, they have to be in a line.
Right.
This is what he said.
Right.
So you're talking about how they're turned 90 degrees from one another? I'm sorry.
No, I mean, when you will position them, the inner rings, the gravitational, they have to go in one line.
Oh, yes, I understand. No, I just threw it on the table. I understand. So I would turn it so that it's in line with the other one over here on the other side then, right?
Yeah, exactly. Or what I understand, you creating the separate, it's like, because he mentioned also you can make from one set of coils. This is your idea, yes? To make not to make in a stacker like one on each other, but you're planning to make it like like star formation from them just by using one set.
That's correct.
Okay. Oh, it's actually it will be interesting to see. In this case, I don't know how you have to position.
Yeah, it's hard to say. And it makes sense. Well, the 3 units, they are always on the same plane in a way. But to try to keep things as consistent as possible, I guess, is the main thing.
Yeah. Okay.
Let us know any results you get. It's an interesting looking structure there.
Yes. Yeah, it's kind of motley right now. I haven't finished it quite yet, but hopefully it will look much better before it's done.
Well, thank you, Robert.
Thanks, guys. Appreciate it.
Okay, anybody else that has things to show and tell? Oh, speaking of Robert, Robert's been busy.
I'm still working.
And
every time Robert's picture comes up, I feel so warm inside.
And what's your theory on this one, Robert?
Well, this is just a sort of tetrahedral star formation assembly of the coils. I don't know, the bottom one just probably be sitting vertically, but maybe with the capability to rotate inside. I don't know, just sort of visually thinking.
Have you guys all seen the Hoberman sphere design? Anybody have seen that?
I haven't.
No, what is that?
It's a sphere that expands and contracts. It almost looks like the tetrahedron that you were showing earlier, but it expands and contracts. I was anybody on something like that. Expand and contract.
Is that the one that's you squeeze from the outside, it sort of collapses into a jagged sort of shape, and then when you expand it, it becomes a spheroidal? I think I have one of those. Yeah, I got one of those.
I think Dan Winters has something similar to that. Is that anybody familiar with Dan Winters? Is how he twists it into. Go ahead.
I'm so sorry. Yeah, no, I've seen him use them quite often, though. Yes.
I don't know, would this create a field inside?
Can you flip this over where the bottom's the top and the top's the bottom? So you get your star formation.
And the nice thing is that the structure itself will provide a very nice base. Should be quite stable when it's sitting on the table.
Yeah, if you tie these red coils together where they're closest, it will be self-supporting. Yeah. And then this top one, this top blue one, you could kind of have it rotatable to maybe shape the plasma field or rotate it. To create imbalance maybe in the system.
If you expand them out and have the frame that it fits in, like if you expand so it's not so tight together. If you expand them a little bit, then you can build a frame that everything holds together. Of course, you could make it self-supporting, like you were saying. We're trying to do this with our star formations, but our red coils, they're sitting more straight up and down, and our top coil is in the same it's straight up, but you're using a whole different theory.
Yeah, well, this is using sort of 4 axes instead of the 3 axes of the that's usually used. This is using Buckminster's Fuller's sort of geometry, where he's using the 4 axes of the tetrahedron as the axis that you would build around, instead of the 90 degrees that your axes come together at 90 degrees. His are oriented that they don't make a 90-degree connection. They're more like he's using a lot of 60-degree angles instead of 90 degrees.
What you're really trying to do is have 4 plasma balls to form another plasma ball in the center. So I don't see why this particular orientation wouldn't be viable, because you're looking at the orientation of the ball inside the plasma ball inside the blue gravitational unit. And
yeah, and
go ahead.
I just noticed that if you look at these upper 3 red ones, their faces, if you look at the plane that they're sitting on, they're pointing into sort of like down here where they would meet, while the blue ones, their axes are going through towards the top. I don't know if that would make any interesting.
Which inside those blue ones, you've now created a free plasma. 4 free plasmas which interact and form a 5th one in the center of the whole unit. That's why I thought if you expand it out a little bit, it would, like you just did, would be give you room for you. Well, of course, the plasmas are going to expand and coast as far as they want to until they want to return again.
So what I was saying is that these red axes would come and join together here, while the blue ones, the axes of the blue would kind of be coming together up here and going to infinity, going away from each other down this way. And the red ones would comment join down here. And that would maybe create a, magnetic would be concentrated here, the gravitational concentrated here. So there would be a differential and maybe have a flow somewhere in here in between the interference focal points. And then with this bottom one, you could control that.
I think we better try it. Who wants to build this one? Our build of the week. Well, soon we'll have the capability of actually just implementing almost immediately.
When you think of this, it's like our star formation. It's a variation of the star formation.
Mm-hmm.
Like Robert was showing, except the plane of the coils is not straight up and down, not on the 90 degrees. For yours is that, you say 60 degree, Robert?
Well, it's based on the 4 axes geometry. You have, let me get out of this drawing mode. Yeah, it's based on, if you can imagine the planes of the red ones.
Yes.
And
yes.
the perpendicular axes going through the center. So you would have 1, 2, 3, 4 axes coming and joining at the center. So that would be your coordinate system, would be 4 axes. Instead of, having the XYZ axis, it will have XYZ and C axis, 4 axes that are oriented at, in this case, it would be more than 90 degrees. But that comes from the 60-degree faces, triangular faces of the tetrahedron, which I think Buckminster was saying that that's how nature designs. It doesn't use 90 degreeness, it uses 60 degreeness. It's just another way of representing your geometry.
So the way Robert Stubblefield was making his frames, he could set up this triangle and these would fit into his triangle.
Yeah, well, I don't know. You probably don't even need to have a frame if you can orient them like this and
tie them together.
And it would be self-supporting.
The bottom one, you'd have to tip it over to be self-supporting, wouldn't you?
Which one? The blue?
Yeah, well, it's not going to ride very easily on that circle, but if it's tipped over, if it's upside down, if you flip it over, top to bottom.
I mean, you would, as I understand, you need to keep this off the floor anyway. So you would probably have a stand, maybe a cylindrical stand that this would sit on. So this blue coil would not touch the floor. It would sort of hang in the air.
So you like you like the orientation of this, the way it is.
I mean,
this is your preference.
It doesn't really matter. You could put it upside down because the fields are gonna interfere the same way no matter which way it's oriented. It's just where the gravitational focus and magnetic focus are would be sort of flipped upside down. So if that matters, then you would orient it in one way or the other.
I think we need to also consider the net effects. Let's say if it's in a spaceship configuration, this would be more in this orientation where the single reactor is on top would be more akin to the 3 pods at the bottom of the spaceship and then the single pod at the top.
So this way?
No, the other way around.
This way.
Yeah, that's right. So the 3 reactors, no, the other way around. So the single will be on top. Yes, and the 3 will be at the sides. So the 3 will basically give you the directional control, moving sideways, and the top will give you the positive positioning. If anyone remembers Bob Lazar's sports model of spaceship, and if you remember the drawings that came out of that, that's sort of what I can envision by looking at this arrangement in this way.
How would you orient this blue one on top? I was thinking it would be movable, so you
that's
could
the
also
that's the steering wheel.
This
Yeah,
way also.
It seems like a good steering wheel to me. It should.
Yeah, that
You
way
just
as well.
aim it where you want to go, and that could go up or down. And if it's sideways, it would tend to go in that direction sideways.
Yeah, it looks like a kind of control panel, or even like, you know, maybe how to extract the fields, because you can even bend it out of the gravitational, the magnetic, I mean. And it's will makes the, you know, the field, you know, how the field interacts between.
You could also raise it vertically from that position a few coil diameters and then rotate
you know,
it.
What I think is missing there.
Yeah, yeah.
I think they need a middle one inside. In the middle, there have to be another ring, because also the Mr. Keshe saying, you in the middle you stuck to top each other. Like now, when you have the top one, you could do it another one inside. So like that, your side rings will go in the side, because usually also what Mr. Keshe was saying, if you have a let's say against ball, you have to make at least 2 between same size of balls to make you know, how to say, space for the fields to travel. But when you're making closer, so you again have another different effect. I meant in the middle another set of coils, like kind of to have 5
smaller.
No, not smaller, same size. It's just your sides will move out because they are still too close, in my opinion. Because right now you're making the star formation. If you make star formation, they have to be a bit further from each other. So it also will affect your connection.
Well, it's worth a prototype. So what's so nice about this is if all
4 blue rings rotate, because this is equilateral. It doesn't matter. The side can become the top very easy.
Right. It can be.
Everything's equilateral.
I just thought, what about if, like example, if you make in a middle where would be the free plasma, and by moving the inner core, you know, side or up or down, you would have the effect what you looking for. Because in this case, it basically move all free plasma, and there was also even like some animation where they was showing like how they was trying to, you know, move the free plasma to one point to another. And if you move, let's say, the plasma up, it's supposed to move upwards. It's like you're increasing magnetic field. Did you grasp what I meant?
I think you were saying if you move the blue one, you make these movable also.
No. What I meant, like example, you make a structure when you are able to put inside where would be free plasma another set of rings, and then that set of ring, if you're able to move inside, example, if you have a one set of coils made CO2 another copper oxide, if you move the free plasma closer to inner set of ring closer to CO2, you will have different effect than if you move it to the copper oxide. So
okay.
like that, you can also, you know, increase what you want to extract or what strength to, you know, maybe how fast you want to travel. Maybe this could be also the way.
Yeah, there's a lot of variations, but we just first need to prove the concept.
Yeah, it's true.
Before we go, further. If someone could make it, you know, give us some feedback on what they experience, what they see, that would give us some basis to sort of go on, improve.
How would you connect all of the gravitational together and all of the magnetical together in this one?
Yeah, I would think so.
Okay, I'll see if I can make it and test some of it.
So how would you incorporate the capacitor battery?
Batteries.
I don't know. You know, I was wondering that too for the star formation. Do we put batteries on both gravitational and magnetical? Since they're all hooked together?
That's how I understood it. That means, let's see, the positive of the battery goes into the gravitational, and the negative of the battery attaches to the magnetical. So it attaches in series.
So one battery would do then, right? You're just connecting
An array of batteries. I would think, like what Mr. Keshe said, three sets of 4 arrays. Connect them together and then connect that to the star formation. So that will be 12 batteries connected in an array.
Right.
You may not have to use an array here, but you got these vertices. I can't draw it, but you see it's just as the red ones there's a vertex between where the red ones join.
Mm-hmm.
And there's a space between them. There's where your batteries sit. In that little triangle there that you're showing me at the top.
Mm-hmm.
That's where, and so there, I don't know how many vertices you have. 4? No, yeah.
Yep, you're gonna have 4.
And so there's where your batteries sit. I mean, I'm just looking at the form of it first. When I look at the form, where am I going to put my batteries? There's where I would probably want to put them, because I have space to put them there. I was trying to forget how to, I would see if I could make batteries that I wouldn't have to put them in parallel, and I wouldn't. So I would try to figure out how to do that. Because I'm just looking at the form. I'm not looking at read too much of the theory yet.
Well, I mean, if you can see the coils, the magneticals are closest at these points. If we locate something in here, it would maybe amplify the magnetic. And if we put something where the gravitationals get the closest, amplify the gravitational with locating the batteries instead of like at the where they are. Well, actually here all three come closest together, while here two come closest together. I'm just thinking out loud, what would be the optimum location? Because here I'm thinking the fields will create some kind of a planar field here, but I don't know, depending which way the windings come together, they may reinforce each other or kind of interfere negatively. So that could also play some effects which way the windings come and interact together. If they're like both are one turning this way, the other one turning this way, they would sort of create a direction in one way. If they're both turning clockwise, then they would dissipate each other. So we got to look at that, how they play out here.
The question I would ask myself, because I don't understand my plasma good enough, and I don't understand these coils good enough, and I understand the flow of plasma and certain things like that, is why on earth I can't put batteries inside the coils and then build my coils outside of my batteries. And so I ask myself, I look at that. Now my battery is basically inside my my coils, both my gravitational and my magnetical. So I've set it up to where my battery's sitting in the core of my coils. I don't know if that's possible.
Sounds like a winner to me, Danny. It simplifies a lot of stuff and makes it so much more elegant to. But the thing about it is, like, is what's inside of these coils? Is it plasma that's rotating inside of the core of the tubes or the core of the coils? In which case the battery may interfere with that the flow of plasma. Of course, you should be able to develop the battery so that it doesn't interfere with the flow of plasma if it's properly nano-coated and right materials and so on. So why not? It makes a lot of sense, actually, because we're not so much interested in the fields inside unless we're creating some sort of superconducting plasma that doesn't want any interference at all inside. Maybe a plain tube would be best in that sense. Or is the plasma created more on the outside of the tube or coil, in which case if it flows on the outer surface, which is actually more likely, then this kind of setup with the battery inside could be a very good way to go, I think.
Because we're wanting to get the plasma to flow, right? That's the purpose, to get the plasma to flow.
That's the main idea, it seems. Yep. Create the free plasma would be the main goal. But yeah, it has to start with creating a plasma.
I actually was thinking about something similar as well. Just instead of the battery, I thought about the GANS ball, and you can make it like one wire come out from the magnetical, one from gravitational, and outer part you can, if you need, you can cover with some like let's say magnetical. You can do it with aluminium and gravitational with the copper to have the different fields, and then you connect to those wires. Because if we extract from the inner core, the energy will be much stronger. The flow will be stronger. From my opinion, right now we use just fields. We don't have we don't show the plasma where to flow. We didn't reach there.
Yep, and even in a spaceship configuration, the whatever is driving the star formation reactor is going to be within the spaceship configuration, which means it's going to be sitting within the field. So let's move it even closer to the field so that it would be able to work more efficiently. So putting it in the center, I think it's a very good idea.
Well, one of the ways we're getting the plasma to flow now is to put a load on it so that the plasma goes to where the load is, so it flows to the load. Isn't that what we're doing, Rick?
I believe that's one of the basic.
Yeah, the load, I guess, the load.
I believe that's one of the basic
potential point.
One of the basic laws, I think, is yeah. So how would we create a load other than internally in the system?
Why we cannot make the inner core as a battery, like we make layers, like the plasma battery does? And we take, yeah, just
spherical sort of ball with layers.
Yes. Yes. And then you have one wire which comes out, which would be magnetic, for example, and the outer, which will be covered with different materials. This you drain from there, and like that you have your magnetic and gravitational. It's almost like you're making those rings of set that you have now, but like three-dimensional, like in a ball, sort of. Because you have inner GANs with a wire which goes through, and then you have outer. It's like a set of tube. It's like a ball inside of ball.
Yeah, I can make that up. Regarding the battery is, as I understand, is just to start the flow. As soon as it starts flowing with the feedback returns that we create, it should maintain itself even if we disconnect the batteries. It should self-sustain if it has a feedback.
So is there a need for a load with a battery? The battery won't flow if there's no load.
Yeah, the battery can become a load if the plasma field becomes stronger than what the battery can supply.
What if
Right?
what if the
Potential
load
difference.
what if the load was say planet Earth or the moon? Say the load was the moon, and we used that and focused on that as the load, the external load for the whole unit. Would not the plasma of the unit be attracted to the plasma of the moon? Let's say as the maggrav fields should interconnect, and you could provide just the gravitational to each other rather than the magnetical. You could then adjust the load toward the Earth as the magnetical for repulsion, and gravitational toward the moon for attraction, and bingo, we'd be on the moon.
Possible.
Would the walls of the ship be considered a load?
That's what I was thinking as well. The spaceship configuration itself, as well as to sustain the spaceship configuration and positive positioning wherever you want to hold the spaceship, as well as supporting the occupants of the spaceship. That would be the load.
Well, if you consider load being any potential lower than the plasma, and there will be a flow from the high point to low point. So anything that's at lower level than the plasma, it's going to become a load. It's going to absorb, I think, plasmatic energy.
Yeah. So, in order to in order to maintain that so-called boundary effect of the spaceship configuration itself, in order to create the demarcation, and in order for it to stay in a certain position, that would be an exchange of flow. That would be a flow of plasma. So that's why maybe we can consider the spaceship configuration itself to be the load.
Yeah, that point, that surface where it comes to a balance, is going to be created due to the gravitational being in balance with the magnetic, right? So
Right.
at that point, there shouldn't be any flow. I don't know. I'm thinking there, if there is flow, that means the magnetic is more than the gravitational, or gravitational is more than the magnetic. So there's a flow. But when they come to a balance, the flow should, I guess, the virtual flow, maybe there's still flow, but it's somehow it's balanced at that point.
For the structure itself, yes, it will reach that balance point. So that's when you get the full structure of the spaceship. But at the same time, the spaceship needs to position itself at a certain point in this in within the Earth's, let's say within the Earth's atmosphere. You want it to hover 20 meters off the ground, or maybe 1 kilometer off the ground, and that condition is always changing because of the way the gravitational field of the Earth works. It's like riding a wave. So there's always uh, an instance where you'll be looking for that equilibrium. You will have that equilibrium, and then the next instance you won't have that equilibrium, and you need to readjust. So that's where the flow comes from. Think of a ship riding the ocean. You know, the waves. It's traveling over the waves, so it's always moving up and down.
Or a helicopter in the wind trying to hover.
Yes, exactly. So, although it appears to us that it has found the balance, it needs to constantly be balancing itself. If it was just to hold its previous position, it will move out of position. No, let me rephrase that. If it holds its previous state, it will move out of position. So it needs to constantly balance itself.
Okay.
Yes, so control systems are important. What's
Okay,
the,
Rick,
what do
I'm
we
gonna-
got here?
I gotta ask another question to you, Rick.
Okay.
Okay, so I'm still thinking about the battery inside the coil. And now with Armin's way of making the little springs to connect the wires, inside you change from one kind of wire to the next. So you're heading down, you're making your gravitational coil. I'm talking about the coils we're making now for our stacker units and our perpendicular units. So you start out, you're coming in with one wire, and you're starting your gravitational coils, and you're turning them, and eventually you'll come around and you'll feed the wire back down the inside of that coil. But as you're turning these coils, say the gravitational, you change to a different wire. Instead of copper, you now change to nickel by using Armin's spring technique. Now you've changed a variation in gradient of the flow of that particular plasma. And so as you're going around inside that coil, you can change the kind of wires that you're using. Since I have titanium, there's nickel, there's aluminum wire, there's zinc wire. You can
Don't forget, when you're using directional flow, don't use different wires, use the same.
Well, I was trying to figure out how to make a battery inside the coil.
Battery is a different battery. You can use a composite of different materials.
I'm trying to make it all in one unit, the battery inside the coils. I'm making supposition to see if it can be done.
Yeah, like what if we took the battery that you made, Armin?
That's all.
What if we took the battery that you made, Armin, that you showed us, the small one with the little different kinds of metal wire coils, and put that inside of either a tube or a coil that goes...
It is the tube too. Yeah, tube
Right.
into the tube.
So what about making that in...
Coil on top of it.
So it's going to be made into like maggrav power unit coils like that?
Yes, but it's capacitor, and you can use different coils because you are here.
Second here.
Sharing.
If you look at it, if you put the tube inside the aluminum tube, okay, but just but understand, if you put too much in the caustic, aluminum dissolves. It becomes like a powder. So when you dip it, leave it like a few minutes, then take it out and then dry it. And it becomes puffy white stuff, and inside this copper pipe, it will be the same. So it's already in nano state.
Yeah, what about putting...
Here, if I put this one from this side, which is magnetical, and I can add one more coil. Here, back to the feeding, this line. But I'm now taking from aluminum. Okay, magnetical is taking, from, you can put even brass, actually, three different materials.
Okay, so could that be put inside of a tube or inside of a bigger coil like in the MagGrav unit?
No, I'm just trying to create, the battery and capacity.
Right. So if we put that inside of a curved tube, like a circular piece of 1/2 inch or 3/4 inch copper pipe that was bent in a circle, would that work as a field generator?
Different winding, you can even put on top of this one, just for a GANs, to hold the GANs, because you have to create a surface that you can, not wrap it up the GANs like we doing in a bead. Like this guy. Oops. It has to be made perfect, actually. When you wind perfect, it will go 1 inch each other. Yeah. So you take a magnetical and you take a gravitational. Now you put this in a GANs. I don't know other way or what, if you can nanocode, and wrap it up. It's the same as a tube.
Hmm. Yeah, lots of ideas here. Hmm. Okay, thanks, Armin. That's another good look at that idea there of the multiple wire combinations. So we all need to be building these batteries, I think, and coming up with our own ideas and tests on them. Interesting.
Guarantee the gradients of the field, because it's different materials, right? If they're in monocoat.
Yeah, even electrically they'll work in a certain regard, but if they're nano-coated, they shouldn't be actually touching physically, so they can't be doing that kind of thing, and they'll be creating plasmatic currents between them, and all kinds of interesting things could take place there, I believe.
And then you have your direction.
All right, anything else to share, ladies and gentlemen?
Yeah, I don't want to share anything because that's gonna start a new discussion.
Another
So
discussion, yeah. We
let's-
should wrap it up. It's coming up on almost 4 hours. So okay, let us wrap it up for today. I'm sure we could go on for hours and hours if we really wanted to, but
Thank you, guys. I have to leave.
Thank you, Armin. Really appreciate your input.
Thank you, Armin.
Yeah,
Thank you, Armin.
Goodbye to everybody.
Guys, may I ask a last question? Hello, guys. This is Hannibal.
Sure.
Very last quick question to Armin.
What is it?
Armin, is there any difference connecting in the MagRap system the coils in series or in parallel?
Okay. What you do in series, you add. What you do in parallel, you guarantee.
You guarantee. Okay. Okay, because I placed 2 coils. I built a system with just 2 coils, and I put one on top of the other to get a feedback, as it was proposed by Mr. Keshe, to get a feedback. So, but I put them in series. That was the idea. I'm testing now. So
You have to put in parallel and series.
parallel and series. Okay. Okay. But I tried that. I don't want to.
You guarantee the flow because it's there.
Is what?
Because you guarantee the flow. If you have a, capacitors, you put one in parallel and three in series.
Okay. 3 in series and 1 in parallel.
No, three in series and three in parallel.
Oh, six sets. Okay. 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 Well, thank you. I don't want to delay you anymore because Rick was.
You can do so many variations.
Well, that's the thing. We could go on for hours and hours and hours and hours and hours on all the variations.
Remember the winding, the flow, how you directed it.
Yeah. Okay. Well, next time, next Tuesday, I will see the.
Try opposite fields too.
Try what?
Try opposite too. One clockwise, one counterclockwise.
I was thinking that. I was thinking exactly that. Yeah.
There's so many things you can do, guys. Come on. 24 people. 24 people do one thing.
Well, there are so many options, many variables. I will test and see what I can do. Thank you, Armin. Thank you, Rick. Thank you all.
Thank you, Annabelle. And thanks to everybody. I think we're going to end it now. Oh, geez, I have to mute all because suddenly somebody came in and everything's became unmuted there. Okay, that's a little better. I'm going to cut things off here now and end it for today. So once again, thanks to everybody. Special thanks to Robert for his visual presentations. Always welcome, and everybody's input is highly valued here. Whoever you are, doesn't matter. It's all good input, so appreciate it. Okay, I'm going to wrap it up for today. And we can say our final goodbyes if you like.
Thank you, Rick. Thank you, everyone.
Thank you, Rick. Bye, everyone. Everybody.
Alrighty, I'll stop the live stream.
Goodbye.
Thanks to everybody on live stream as well. I didn't answer any questions there today, but just didn't have that available right today.